All right, hello everyone, and welcome to the 10th International Conference on the Use of R in Official Statistics. So whether you're an R learner, enthusiast, or professional, we're very excited to have you over the next 3 days. I just have a few introductory remarks and housekeeping items to go through before we officially kick off this conference. So my name is Kate Burnett Isaacs. I am the Statistics Canada representative on the organizing committee. We are a fabulous team. We from across Europe and Canada, from the National Institute of Statistics in Romania, Statistics Austria, the Central Bureau of Statistics in the Netherlands, Ecological University of Bucharest, and the University of Bucharest. So of course, we're statisticians, so we like to keep track of these things. This conference has been ever growing over the last 10 years, and we're very excited to see what kind of participation we have this year. We're already off to a very good start. We have 42 presenters this year across 22 countries. And this is a special event, not only because it's the 10th anniversary, but it's the first time this conference has been hosted outside of Europe. So Statistics Canada is very honored to play that role. We have a very excited agenda over the course of the next 3 days. And of course, we extend a warm welcome and are very excited for our keynote speakers, Julia Silge and Eric Kolazic. So my housekeeping items. So we are asking that all participants ask questions on Slido. So you can go to www.slido.com. The agenda has all the numbers, so there's going to be a unique Slido event number for every session. Also, these numbers are going to be put in the chat before every session. The conference is also going to be recorded, as we are going to make the recording available after the conference for later viewing. We are also, just to note, we have pre-recorded presentations, and they will be available on the conference website at the end of this event. Also, a note for all presenters, we strongly encourage you to submit your abstracts for your presentations to either Survey Methodology, Romanian Statistical Review, or the R Journal before January 15th. So without further ado, I would like to turn it over to Anil Arora, the Chief Statistician of Statistics Canada, to officially start the conference with his welcome address. So thank you very much, and over to you, Anil.
Well, thank you very much, Kate. Welcome, everybody. Welcome to Canada. We really are proud to host this year's conference. I'm told it's outside of Europe for the first time. It's important recognition of the great work we're all doing with R here in Statistics Canada and throughout our program areas and the partnerships that we've been building with our international colleagues in the open source space. We see the value that R brings to our core business of delivering insights to Canadians. Adopting new methods and tools like R is driving our modernization agenda, and I'm really excited to see the enthusiasm among our analysts and that the tangible results from this new way of working are already improving day-to-day work within the agency here. I want to recognize that this is not just about using technology. It's, of course, bigger than that. This is about fostering a culture of innovation, continuous improvement, and openness, where we are looking for how we can better serve users, where we take smart risks, experiment, and collaborate with each other to explore what's possible and find practical applications that actually strengthen the work that we do for our respective citizens. The key principles of working in the open are, of course, transparency, inclusivity, releasing early and often, collaborating with our community and building that community. This not only ensures that we are being purposeful and leveraging the value of R, but that we are influencing the culture and promoting excellence across our national statistical organizations. And for that, I say thank you to all of you. This is important work, and I encourage you to take advantage of these next 3 days to, of course, to listen, to share, to challenge each other, and to find renewed purpose, to build partnerships, and to continue bringing that enthusiasm and contributing to this community. So I want to thank you all for being here and welcome you once again to uRos 2022, and I wish you very productive conversations. Thank you very much.
Thank you very much, Anil, and welcome everyone. We are a little ahead of schedule. So we are up next is the scientific session, R in production automation. So I will turn it over to Anna to get everyone set up, and we may wait just a few more moments to get started at 9:10.
Hello, everyone. Welcome at this edition of uRos. I am very glad I can participate and that I can see a so large audience. Here we will introduce the session R in production automation. We have in this session 3 presentations. One is from Eurostat representatives, one is from Statistics Austria, and the third one is from Romania, the origin country of this conference. From now, I want just to mention again about, don't forget about the Slido channel for questions and answers. Please feel free to use it. And now I am preparing to give the floor to the first speaker for the presentation Eurostatistics from PDF format to interactive web visualizations using R. Mrs. Rosa Ruggeri Canada from Eurostat.
Thank you for inviting us to this conference. My colleague Piotr will put the slides on, and I can start to telling you that this is work done mainly by my colleagues Piotr and Annette. We also had Johannes with us for some months, and I am just there to give you the context, and then Piotr will give you more about the technical aspects. Piotr, can you go with the first slides, please? The aim of this presentation is to show how we went from Eurostatistics, that is a monthly publication giving an overview of macroeconomic situation that covers many macroeconomic indicators, both for European Union countries and European Union aggregates, Euro area and European Union, and some main economic partners. The challenges here are that we put some comments on our data, then we need to freeze the data, and we need to be very fast in producing our publication, because if the publication comes out 2 weeks after, the information will be already very old. Then if you want to give some comment on your indicators to the public, you need to be fast. This publication, it was published starting in the 80s. And as you can see in these images, we were working a lot to improve the graphs. And in the last version, we had very advanced graphs, 230 figures and 35 tables with multi-scale and multi-indicators. You can see here that there is really a challenge. Then what are the pros and cons of a PDF format? A PDF format is more suitable for reading sequentially. You can have advanced presentation, but can I have the slide before, please? But you cannot really move inside the information. You cannot choose what to look at, while users for the moment are keen in picking pieces, having information shown in small pieces, and mainly to have an interactive tool. Then our main challenge was, can statistician using R going in dissemination of statistics in a new innovative way? And the aim of this presentation is to answer, yes, we can. As statistician, we can invest in programming R and reach nice tools that have those characteristics, being interactive, being rapidly updated, and giving a good service to the user. On this, I will give the floor to my colleague, and they will show you how we realize this improvement.
First, I would like to say a few words on how Eurostatistics visualization has been developed. So there are three main blocks on which we build our visualization web pages. So we have R Markdown, which is included or integrated with RStudio. As well, other three main building blocks are packages like Flex dashboards, Plotly, and Depler. R Markdown is a file format for making dynamic documents with R. It allows to combine an analytical text with a code producing, for example, charts. As an output, it facilitates to create documents in different formats. We can create web pages with no knowledge of HTML. Thanks to R Markdown, web pages can be reproduced and updated much faster. Flex Dashboard uses R Markdown and adds additional functionalities which help to publish a group of related data visualizations as a dashboard. For this purpose, it provides predefined layouts for HTML pages. In particular, it includes a storyboard layout, which is presented on the slide. This layout allows presenting a sequence of data visualizations and related commentary. In my view, this layout has a big advantage in communicating main messages on data. The layouts of Flex dashboard help to group interactive figures in Plotly, created in Plotly. At the final stage, the layouts and charts had to be adapted to Eurostat's branding and standards. We had to also ensure that our output can be displayed on desktops and mobiles. In particular, it was quite a challenge to get a satisfactory output in mobiles. Here is the production workflow for Eurostatistics web visualization. It is updated monthly. Firstly, data are loaded from Eurostat's online database and OECD's online database. Additionally, some data are downloaded from Excel files. Then all data are compiled into one CSV file, which is an input for our RMD file. Secondly, the analytical text is written and placed in an Excel file, which is the second important input for our RMD file. In our RMD file, we use a very useful package called MetaDis. This package allows to use HTML metadata tags in our RMD file, which links to specific parts of the text in the Excel file. This is very convenient not to include an analytical text directly in an RMD file. This indeed speeds up the update of Eurostatistics visualization. Eurostatistic web visualization includes three main sections: economic developments, growth assessments, and trend cycle estimates. The economic developments uses a storyboard layout to present a sequence of visualizations for some selected short-term indicators. We have a horizontal sequence of boxes with main messages on those indicators. For each indicator, we have two charts. We have a line chart and a bar chart. In a line chart, we have two plots for the EU and the Euro area. You can select countries. And when you hover over plots, you can see values for specific time periods. On the right side, there is a short data commentary. So we can move indicator by indicator. You can see charts with a short comment. The same storyboard layout is implemented for the growth assessment section. In the section for trend cycle estimates, there is a group of charts presenting trends and cycles for GDP, employment, and industrial production. The results for three different methods are presented for each indicator. Finally, it can be concluded that the Flex dashboard facilitated the development of Eurostatistics interactive visualization. We would like to recommend this tool. However, knowledge of CSS was needed to implement Eurostat style requirements, and it took indeed some additional time to fine-tune the final layout. Additional work was also required to improve a mobile version. But the publication process is now made easy. Storytelling with data is a critical aspect of data visualization. In our view, communication on data has been improved by the storyboard layout. Rosa, would you like to continue?
Okay, I can take over here. One of the characteristics that we didn't have time to show is also that you have a slide banner and you can zoom on your graphs. So you can do a lot. It will be nice if you take some time to play with our tool. And please send us back your comments, because we are very glad to have comments back from our user. Then what I want to stress is a little bit the organizational part. To have a project like this, when you are in a big organization, it's true that this was mainly managed by statisticians, but if the organization is big, it's better to take in consideration that you can also cooperate with communication experts or IT experts, at least for the fine-tuning, although the bulk of the publication is done by statisticians and is based on statistics. We find that this is a particularly great solution when you look, sorry, I think my video is off. When you look at, when you have to publish, when you have to publish information at high frequency, as is the case for monthly publication, because you can have even more advanced presentation tools, but usually this can require a much longer time to be produced. While we have a very short, in some days we can do everything. And you need some, clearly, it's not just the development.
Get off the screen.
To maintain it, you also need basic air knowledge, and if you get some support, it can be good, mainly for evolving requests of your IT environment. However, once that you have done your first development, adapting it can be performed with low resources. I see some question in the slide about security and so on. Let me stress, and then I will give the floor back to Piotr, that the output of this publication that you could see live is HTML pages. Then you don't have any kind of particularly security worry, because you just generate interactive HTML pages. And I think maybe Piotr, you want to answer further questions?
Could you say what are the questions?
Shut up.
The
Yes.
question are, you mentioned a package meta something. How is the complete name?
It was which package? Which so we had so we used 4 main packages: R Markdown, Flex Dashboard. So this is the main package which provides layout for our web pages. Plus we use Plotly for creating charts, and Doppler, which is more for loading, manipulating, filtering data. And also, I mentioned there is quite useful package, MetaThis. So this package allows to put metadata tags in RMD file. So we do not have to include our analytical text in an RMD file. So analytical text can be written outside our RMD file. So this is very convenient when we want to update our visualization tool.
Okay, then we had another question. How do you gather application security requirements for your web application?
I think this is managed by our colleagues in dissemination unit. So we just send to them the HTML pages and other supporting files which we created in our RStudio to our colleagues in dissemination unit, and then they handle all security issues. But as I said, I don't see any issues relating to security issues. As I said, those pages are not updated dynamically online. So it means that we update our visualization tool each month once. So they are not, the data which you can see in our charts are not updated dynamically.
Let me complement on this. This was a choice we did because our aim was really filling the storytelling. You cannot have a storytelling with live data because they will change. Then in order to give some storytelling, we decided to have a kind of freezing, and we freeze the data once a month. We choose a date where you can maximize the important releases of indicators. Then we have some other question. What is the setup for hosting the dashboards? But I believe on this Piotr already answered. We generate HTML pages that are integrated on Eurostat website. Yeah. Then we have, does R Markdown support CSS scripting?
Yes, so indeed, absolutely, you can use CSS scripting for any formatting purposes. I think it is very useful to fine-tune, let's say, the final layout, because the Flex dashboard provides you a kind of rough template. And if you work in an institution, usually you have to adapt to some style requirements. And CSS indeed is very helpful to make this fine-tuning. And indeed, you can use CSS scripting.
Then I will read another question that ask the chair if we can go on, because I don't know how much time we have, but there is an important question that says, are the R Markdown files, related scripts files for Eurostat dashboards available for the general public to view? We share our files, just ask us. We have a GitHub website, Piotr, I don't know if this is public or restricted access.
It's not public yet, but I think I don't see any problem that we will share this. It's maybe we could mention that we at Eurostat we will develop much bigger project in which we would like to develop some tools which would facilitate to create any kind of visualizations. And indeed, we intend to, and those visualization tools would be available for statistical offices, for national statistical offices, but I understand also they would be also available for general public. In case of our tool, I mean, if there is any request, please contact us and we can share with you our RMD file. It's important to mention that we had to really use this RMD file, you have to properly format your data which you use. So it means that this requires to adapt your data which you intend to visualize.
We have a last question, if we consider Quarto as a developer.
No, we have not considered this. We took Flex dashboard because I would say this is quite easy to use, to develop. It has predefined layouts. Of course, it has some limits because you have layouts, and if you want to make any changes, if you want to place logo, maybe, I don't know, in one place or another place, you could struggle a little bit. But as my colleague Rosa said, we didn't have much time to develop our tool. We had a very short time period. And this Flex dashboard was a really easy choice to let's say, to develop our visualization. But we are open to any other packages. I think when we launch our bigger project, we will also look at other possible packages or tools which in R which we could use.
I would like to thank all for the question, and please let me tell that there is a strange comment in the chat. This is definitely not from me. There is my name, I don't know how, but it's definitely not from me. Sorry for this, but I cannot do anything about that. Thank you all, and I don't know if I leave the word to the chair because I think we don't have more time.
So thank you very much.
Thank you.
Okay, we had some technical problems, sorry. So thank you very much for your work and your great presentations. It is indeed very useful work for all the European statistics community and of course international, because dissemination and visualization in this automatic mode is very, very useful. Thank you. And also, it's less time consuming than the traditional one. So thank you so much to you and your colleague Rosa. And now is the time to give the floor to the next speaker, which is Bernhard Meindl from Statistics Austria. Bernhard, you have the floor for presenting us circular letter generation using R, another way of using automation. The floor is yours.
Hello, Anna. Thank you very much. I'm very happy to be able to once again present some of our work at the uRos conference. So I'm talking about our baby steps on trying to find a new approach to create serial or circular letters. So basically letters where some parts of the letters are dynamic. The starting point for this development was that I was contacted, and there is a project at Statistics Austria where they are producing a lot of customized letters. There is a process available, and they are producing a lot of individual letters in a very efficient way. Then I realized that there are additional projects and parts at Statistics Austria which also produce individual letters, but everybody seemed to have developed their own solution. And there are a lot of possible use cases, like you are sending out general information about the survey to the respondents, or sending out reminders if somebody has not yet answered, or credentials for some online survey tool. So there are a lot of possible situations where it's useful to be able to generate dynamic letters. The problem is that most of the processes I saw, they are not really flexible. So there are hard-coded paths in there, or any other, or some other ways that either rely on Windows-based databases or things like that. So it was not very easy or straightforward to create a general new way on how to simplify and standardize things. In R, as we already heard, R Markdown, for example, or Quarto, provide very easy ways to produce individual documents. We can parameterize outputs and create files with different formats, PDFs or Word or HTML. Statistics Austria, we commonly rely on LaTeX templates for these individual letters. And so, as I thought, this is probably the more difficult way to approach things. I was just trying to start with the LaTeX based generation of letters, because I think that the generalization or the move to R Markdown based outputs would be quite easy later. But the goal was to find some way on how to standardize the generation of such individual letters. So the first idea was to actually think about what we need to create such a letter, to produce a lot of letters based on one input. And the most simple definition I came up with was that we need a template. And in this template, we can include dynamic elements like names or addresses or images using a certain syntax, which is in this case \field, and then the name of the dynamic field. Then we need a style sheet, which can be used to add additional macros or settings or general things that should be consistent in every letter we send out. But of course, we can just change the path to the style sheet, but we need a style sheet. And we need data. So in order to be able to create a lot of individual letters based from one template, we need a data frame or a data input where each column of this data relates to one field entry in the template. And then optionally, we could supply a set of assets which are required to compile a document. These are typically images like QR codes or signatures, which are included in the, which are used in the template and included in the final output. The main goal of this work was also trying to make sure that we make use of our existing R environment, which is quite nice, by the way, as much as possible. So we have a RStudio Connect license, and the idea was to build everything around Plumber-based APIs. So specifically, we implemented two APIs. One API that deals with the management of assets, so the images and things we want to include in or attach to documents. And then we have another API, which is the actual job API, where we can submit jobs, check jobs, and finally download the results. This is hosted on RStudio Connect. Then in order to be able to communicate with the APIs, there is a utility R package, an internal package, which is called Schriftverkehr, which is a German noun for, has something to do with creating these documents. But basically, it's a utility package which just makes use of the existing APIs. It allows to create suitable bundles containing the required inputs that can be sent to the API and functionality to retrieve results. And there is a Shiny app, a dashboard, also implemented using Flex Dashboard, which is also hosted on RStudio Connect, which provides a user interface in the browser to manage jobs, to download results, to cancel jobs. And it's also in the background using the calls to the API. So we really prioritize the back end, the APIs to the front end, because we think we can at any time like improve or build another front end once the back end is finished and stable. So just to give you a quick overview on how simple and basic the endpoints, for example, for the asset management are. So we have just a few possible verbs that we can use, or endpoints. We can list the existing assets, we can delete an asset, we can download an asset, a specific resource, or put or upload an asset via the API. And those are stored in a specific directory and can then be accessed from any job that requires these assets. The implementation in the R package is done using simple functions. We're making use of the HTTR package a lot, talking to the API, so we can list the assets using assets show or check for an existence using assets exist, download files to some place, remove assets or post them. For the jobs API, there are a bit more endpoints, but the most useful actually are to post a job. So you basically upload a bundle with a specific ID. It puts the files on the server at the desired place. And if you post to the start endpoint with the specific ID, you can start compiling all those documents. In parallel, using the parallel package, also making sure that we don't block any other work on our servers. We can list jobs, get the current state of the jobs, like the number of files, documents that have already been successfully compiled, or if there are any errors, and so on. Then we have endpoints to finally extract the results. So we can, for a job that contains multiple documents, everything like the TeX files that are produced, the log files and the PDFs, or just the PDFs, or we can download the resources for a single document only too. We can delete the job, which will also stop any compilation processes in the background, or get a status overview about everything what's going on. As I just mentioned, the key idea was an API first development. So the API is the main backbone of this entire process, and it accepts a bundle, which I explained earlier. And the one row in the supplied required input data set in the bundle finally relates to one produced PDF document. And all these field placeholders are replaced by the specific column with the same name in the dataset. In the R package, there are several ways on how you can configure or set up a job. We are using config files in YAML syntax because I think it's very clear and concise way on how to specify parameters. So one way is, which is nice, that you can also define a Git repo where your templates and style sheets are stored. You define assets if you need to, which can be like relative passes, relevant, for example, to the base tier of the repository, or specify relative passes via the assets API. And you need to specify the path to a data file. And we deliberately made it very simple. So this entire process accepts an RDS file, so an R binary file or a CSV file, because such files can be generated dynamically in a lot of different ways. And I don't want in the API to deal with data generation issues. In the package, there is an R6 class, which represents a letter. And just for the demonstration on how the actual process on creating a letter object and starting to create the PDFs is done. So we have the path to a config file, which I showed you earlier. And then there is an initialization function, which takes the path to such a config file. It returns such a class object, which has several methods, like to query the ID or to create, which means to register the job at the server. It uploads the bundle via the API to the server. The start method actually starts the compilation process. Using the status method, we can have a look at the status, how many files have been produced. We have a isFinished method, which is useful to check if everything has been compiled. And there is a download DL download method, which allows us to return the PDFs or the collected results as zip files via the API. There are also, if you don't want to use the ASICs objects, there are simpler functions doing the same thing. For example, we can use the job create function to upload a zip file, so the bundle to the API, and then we have which returns the ID, which we will need later. We can look at the status using the job status function, and in this case, a while function, which just sleeps and checks every 10 seconds if everything is finished, and if it's finished, it downloads the results to the hard drive. There is a dashboard in development where you can get an overview on the number of jobs that have been processed and which were successful, and how many errors and so on, which allows the job monitoring, downloading of results and specific documents, deleting jobs, and also asset management, like uploading, deleting, and listing assets.
Bernard, 1 more minute, please.
Yes, I'm already finished. This is my last slide. As for the future, I'm still trying to find a real-world production case and try to find some friendly internal testers who want to try this out. With them, trying to identify some missing features that would currently block more widely spread usage. Also, there are, I think, a lot or quite some low-hanging fruits, because this is easily expandable, for example, to produce custom mass mails or custom HTML pages. It should be quite trivial. We should move the compilation to an extra server, because currently it's run on our development server, and it takes some resources, and yeah, generally implementing feedback received from testers. So that would be everything from me. I'm looking forward to answer any questions in the Slido
Yes,
page.
you have a question there.
Yeah, I will go there, and I think I've already used enough time. So thank you very much. And
Okay, thanks. And you will answer there. Thank you.
I will answer there. Okay, thank you.
Thank you. Now is the time to move on to the last presentation of this session, which is about some automatic product classification for the price statistics. I will give the floor to my colleague from Romanian National Institute of Statistics, Marian Necula. You have the floor.
Hello, everybody. I'll share my screen. So our work is related with price statistics when using online data to compute some experimental price statistics, we encountered a problem, as many of you know, which work in this field, regarding classification, product classification in some classes according to classification nomenclature. So our work it's regarding the modernization strategy of Romanian NSI. We will try to adopt new methods for statistical process or to integrate some new data sources into the statistical production. So this project, we started to develop a process of collecting data regarding prices through the web scraping from main e-commerce national sites. So we collect around 50,000 records every week. Products must be classified according to categories using the CPI nomenclature, and we due to the high volume of the data collection every week, manual classification of products, it's not feasible. So in this case, we turn to automatic classification. The project consists in using firstly a reduced set of product categories in order to identify the best algorithm and the best vectorization techniques in order to obtain high accuracy. This is our target. So we choose 15 categories from the European classification of items. These are the classes. These are the number of products in each class from which we selected. In total, there are 2,853 records, which were manually labeled by one of our colleagues according to this classification. Another problem is that classes are highly imbalanced. Around 80% is stored in 3 classes, the distribution of the products, which will cause a lot of false classification, false negatives. In order to classify, we explored the literature and identify several machine learning techniques for text classification, which uses numeric vectors as inputs. In order to transform our data to numeric vectors, we explored also a few embedding techniques, transforming the text into numeric data. These techniques were some very simple ones, like count vectorizations, involving counting the number of occurrences of each word which appears in a document. Also using n-grams as tuples between multiple words. Another embedding technique was term frequency inverse document frequency, which the formula is basically this, where the weight is a score for term I, for word I in document J, and TF is the term frequency for word I or term I in document J, and IDF, it's the score for term I or word I, containing the total number of documents. Another embedding technique was word2vec, which uses a neural network trained to reconstruct linguistic context of words. There are 2 versions of this network. One is called continuous bag of words, and the other one is called skipgram. The embedding of a product name was built by adding the embedding of each word and averaging over the word embeddings. Another one which performed very well, it's from Facebook, it's developed by Facebook, it's called FastText, it's similar to Word2Vec, but uses character n-grams besides the whole word. So we have tuples of words and characters. The last one, it's called GLOVE. It's an unsupervised learning algorithm for generating word embeddings. Thus, for each classification method, we tested 9 different vectorization of product names. For count vectorization, we tested n-grams between 1 to 3 over 3,000 features. Using, we transformed this text to vectors, numeric vectors, using these packages in this column. So for count vectorization, we use SuperML. For frequency, inverse document frequency, we also use this package. For Word2Vec and all its flavors, we use Word2Vec package. For fast text, we use package also. There's a API to the algorithm provided by Facebook. We perform also an exploratory analysis and build some 2D visualization of the data sets to see how the classes are separated. The 2D representations of the trained data sets were obtained using a method for projecting high-dimensional data into 2-dimensional Euclidean space. For count vectorization, for term frequency, inverse document frequency, and for fast text and skip-gram. So these are the representations. We can see that the classes are quite connected between them. So also for the Word2Vectors and the skip-gram, the same type of visualization. These were the methods, the machine learning methods used as a combination between document to numeric vector method for the embeddings, and these were the classifiers. So we had a combination between each machine learning method, so logistic regression and all those embeddings, between naive Bayes and all those embeddings and so forth. This is quite a work here. But our environment provides all the tools, all the building blocks. So it was the first part was selecting all these packages, and then to run the algorithms was quite easy, along with the embedding. So here we selected, due to the class imbalance, the weighted F1 score gives more importance to smaller classes. So here the F1, the weighted F1, is the best measure in this case due to the class imbalance. Here we selected the method, the classification method, along with the the word vectorization method, which perform best on the F1 score. The results show that C50, something similar to random forest, show the best performance for each embedding method used. There is a large variation of the performance metrics for different embeddings. The best one, I believe, was fast text. The best results with naive Bayes, random forest, support vector machines with the radial kernel, and artificial neural networks. Regarding the word embeddings, the best results were obtained with count vectorization and term frequency, inverse document frequency for naive Bayes, and fast text skip-gram for support vector machine and random forest. So the future work will involve to use some grid search to parameterize all those machine learning methods. Right now they were set by hand, the parameters. We also plan to expand the sample in order to improve the performance. These tasks, this experiment runs for several days in order to obtain these scores. We'll need to use some parallel programming techniques. Also, our environment provides all the tools here to use some more CPU power for some servers, and ultimately the selection of the best method will be voted on the influence on the price index. So the benchmark or the gold standard will be how the smaller deviation from the price index based on this classification when selecting the products to be included in this set. So this is my presentation. Thank you very much. If there are any questions, I'll answer them directly on Slido.
Yes, you'll have to answer there. Thank you, Marian. Thank you to our presenters. So we are in time now to finish this session and to continue with the next one, which will be chaired by our colleague Alexander Kovarik from Statistics Austria, and I am giving him the floor now for the next session. Thank you to everyone.
Hi everyone, sorry about the delay. I had to unmute myself. So welcome to the second session, methods for official statistics. We will have 3 presentations about 3 different areas: outlier detection, validation, data editing, and STC. And to not steal any time from the presenters, I would ask the first presenter, Marcello from eStat, to share his screen. Please add Marcello to the co-hosting group so he's able to share his screen and unmute himself. Perfect, I see it's working. We see your screen. We cannot hear you so far. Can you unmute yourself, or is that blocked?
Can you hear me now?
Yes, now it's working. And
okay, perfect.
Hello.
Okay,
Please.
so thank you, Alexander. Hi, everyone. I'm going to present briefly the outcomes of an ongoing work related to outlier detection in panel survey data in the IR environment. So basically, first of all, a couple of definitions of outliers. One from UNECE that is basically referred to univariate case. So a data value that lies in the tails of a statistical distribution of uncorrected data. And the assumption is that outliers are more likely due to errors in the observations. And basically, we have a more general one from the monograph from the colleagues from Statistics Netherlands, in which we say that a value or a record that is not fitted well by a model. Here we have a distinction between the univariate situation from the multivariate situation, in which we work with an entire record or the subset of values in a record considered simultaneously. So if we go in the R environment, we have a number of facilities for detection of univariate outliers. I prepared a package some time ago that has wrappers to well-known approaches that are non-parametric or parametric, so in the case of Gaussian distribution, and implements also a popular approach for analyzing data from panel survey, where we analyze a variable observed on the same units but in 2 subsequent time occasions. There are other packages like the extreme values package from Mark van der Loo that uses statistical tests and fits exponential, variable, log normal or Pareto distribution, and also CeleMix developed at ISTAT that consider a mixture of Gaussian models. In the multivariate case, we have popular packages are MV outlier or the RRCOV packages, where the idea is that of fitting a multivariate Gaussian distribution, we estimate its parameters using robust approaches, and then we measure the distance, Malanobis distance of each observation from the bulk of the data. Then we have also the CeleMix package developed at ISTAT that works in the multivariate case. Under the umbrella of recent, I listed some approaches that are popular in the data mining literature or in statistical learning. First of all, we have a non-parametric density-based approach, and in particular, I'm focusing on those that look at the distances between units, so the k nearest neighbor. And this approach ends up with a score that is a function of the distances of each unit from its k nearest neighbors. And it is fully non-parametric, and all these approaches are implemented in the DD outlier package. Then we can apply also clustering-based approaches, and in particular DBSCAN clustering. Here, the idea is that we try to cluster the observations, considering that we have a noise in observing the units. And so the idea is that of separating this noisy observation in a specific cluster. So these noise observations are the outliers. Practically, we work again on distances between the units. The problem of this approach is that we have some tuning parameters, and so it is not easy to tune the algorithm. However, we have a package that implements the algorithm as well as some KNN distances. Finally, I'm also considering decision trees algorithm, and in particular the isolation tree. The idea in the univariate case is quite straightforward. So basically, we expect that we need few splits to isolate the extreme values if compared to the other values. So we use the number of splits needed to isolate a unit as a score. In this case, however, we do not fit a single tree, but we fit an isolation forest, so an ensemble of trees. The nice feature is that basically we have the final score that are associated to each observation that range from 0 to 1. We have also a rule of thumb saying that scores greater than 0.5 identify potential outliers. Unfortunately, this rule of thumb sometimes does not work. The other problem with this method is that the standard method works quite well in the univariate case, while in the multivariate setting we need some extensions of the base method, like the extended isolation forest. The Solitude package implements the base isolation forest, while the ISO3 package has an implementation of the base algorithm and some extensions for dealing with the multivariate case. So in my case, as I'm working basically with panel survey data, the idea is that the input data will be the e-scores that we obtain by using the Dirac-Berthelot approach. These scores are achieved by considering the ratio centered around the Arminian and then multiplied by a measure that should reflect the importance of the units of the values involved in the ratio. So the idea is that the higher is the numerator or the denominator, the higher is the importance of the ratio. This is an example with household data. In particular, I'm looking the expenditures of about 4,000 households that are observed in the survey on household income and wealth carried out by the Bank of Italy every 2 years. Here I'm comparing in the first scatter plot, you see the consumption in 2016 compared to the consumption in 2014. The second plot gives an idea of the distribution of these scores achieved using the Dirac-Berthelot procedure. We have a quite symmetric distribution. The vertical lines identifies the Dirac-Berthelot bounds. So ideally, all the units outside these bounds would identify potential outliers, while the dashed vertical lines indicate the bounds of the skewness adjusted box plot, even if in this case we do not have really some skewness. And we see that Dirac-Berthelot approach will identify less potential outlier than skewness adjusted box plot. The right side plot compares the isolation forest scores with the Dirac-Berthelot score. And here, if we apply the 0.5 rule of thumb, we see that in this case the isolation forest would identify a high number of potential outliers, much higher than those that would be identified by the Dirac-Berthelot approach. This slide uses the same data, but we are comparing the outcomes of the KNN distances approaches with the dbScan. We have 5 different values of, 3 different values for K, 5, 10, and 15. And you see that obviously by increasing the value of K, we increase the range of the scores. But it is not simple to identify a threshold. On the contrary, the dbScan permits to identify directly the potential outlier. They are the red color dots. And so you see that in this case, dbScan identifies relatively few outliers if compared to the other methods that we are considering. This second example refers to the bivariate case. I'm analyzing production and capital of about 500 firms. These are data that are in an R package PDER. So basically, I'm working again with these scores. So I have the scatter plot of these scores of capital versus these scores of production. And the color of the points identify the score achieved by the isolation forest. You see that orange or red color points identify potential outlier. And in this case, the 0.5 rule of thumb seems to work quite well because it's effective in identifying relatively few outliers. Here, as we are in the bivariate case, I'm comparing the isolation forest scores with those that will be achieved with methods that consider the bivariate Gaussian distribution and the dbScan. You see that in the first 2 cases, when I'm assuming a bivariate Gaussian distributions for the scores, basically the procedure, Milanobis distance with robust estimation of the parameters MCD, or the CELEMIX package would identify a higher number of potential outliers than those identified by isolation forest with a 0.5 threshold. So in red color, you see those that will be identified by both the methods, while on orange, you see only those that will be identified by the Milanobis distance by CELEMIX. So it is interesting to observe here that the dbScan clustering algorithm here provides almost the same results of the isolation forest with this rule of thumb of 0.5. Okay, these are tables. I will not comment them, that just show how many outliers are identified by the different methods that I'm comparing. I want to go quickly to the conclusions. So if we focus on this recent method that I'm considering here, so the non-parametric density-based approach that work by using the KNN and all the extensions. So we have some results are sensitive to the decision on K, and in the multivariate setting, we have also to decide the distance function and whether or not to scale the variables before calculating the distance. We have a score. It is difficult to identify the threshold, but however, we can sort the scores in descending order and so start analyzing the data. Obviously, calculating distance may become too cumbersome with a lot of observations, but in R we have some method that permit to efficiently compute approximate distances, even if we have a limited set of distances. TB-scan clustering, the nice thing is that it is quite effective in identifying few observations that have a high chance of being outliers, but the results are sensitive to the decision on the distance threshold and the definition of reachability. And in addition, when we work in the multivariate setting, the distance function and whether or not to scale the variables. Isolation forest, in my view, is quite promising because we do not need to transform the variable, as relatively few tuning parameters that in some cases are not really relevant as in other procedures. The final scores range in the 0-1 interval, but unfortunately, the rule of thumb of a score greater than 0.5 often does not work, so we should analyze carefully the result. And in addition, we should be careful in the multivariate setting because we need to consider, for instance, the extended isolation forest rather than the standard method. So thank you for, I'm done.
Thank you, Marcello, and thank you to sticking to the time. A short reminder to everyone, there's a new Slido channel for the new session. I forgot to mention that at the beginning. And the new Slido is still empty, probably because I did not mention it, but there are 2 questions in the old Slido. So I will, which one, I'm sure it is directed at Marcello because his name is mentioned. And the other one was also just posted right now, so it should be also for your presentation. So the first one, have you looked at methods that can distinguish between influential and non-influential outliers? And maybe I also follow up the second one and you answer both. The second one is, what was the next step after identifying an observation, for example, a business as an outlier?
Okay, so basically, for influential outliers, yes, because basically CellMX package that is currently a reference package in ISTAT that we are using quite extensively is mainly developed to identify influential observation, and a byproduct is also the outliers. I'm not considering up to now other methods that you can find in literature for identifying influential observations. About what's next, so ideally, so we have a problem now at ISTAT because in the past, when we identified outlying observation, we had people that started viewing at the data and checking the incoming data, and in some cases calling back the units, enterprises, for getting in case a correct value or not. Now these people is retiring, and we have to practically use methods to predict the value that we identify as wrong. So in the CellMX package, we already get these predictions as a byproduct of the package, and in some cases we are using directly this prediction. With my approaches, unfortunately, this is missing, and so the idea is that, okay, this is a tool that can be used in the multivariate, mainly in the multivariate setting, but we still need to decide how to treat these outliers in the subsequent phase, avoiding, manual checks of people.
Thank you, Marcello. In order to keep the time, we will move on to the next presenter now. The next presenter is Edwin de Jonge. I already seen him, so I hope he can also speak and share his screen. Please, Edwin, the floor is yours. We cannot hear you, but you are unmuted. So no, unfortunately, your mic seems not to work. We give Edwin a second to figure it out. No, unfortunately. No, still no sound.
What's the name of the person trying to speak? I'll see if they have permission.
Edwin de Jonge. I can see him and like his cam, and he's also unmuted in the list. So I think that's not the issue.
Okay. So Edwin, if you go to the bottom left of your screen, you'll see where the mute button is. There's a little arrow next to it. Try selecting a different microphone. See if that fixes the problem.
Does this work?
Yes.
Yeah,
Edwin,
gotcha.
Okay.
Great. So,
well, thanks. Sorry for the delay. Well, thanks for being here, and I will try to grab the screen right now. Is my screen visible right now?
Yes, that's
okay.
Working.
Thanks. Okay. Well, great to be here at the uRos, and I'm going to present the Validate Suggest package. About data-driven data validation, together with Olaf ten Bos. And without much further ado, well, I'm working at Statistics Netherlands, of course, and I have written a couple of packages, and I'm also author of Statistical Data Cleaning with Applications in R, together with Mark van der Loo. That is relevant since this presentation is on data validation. So as we all know, a large part of the job in official statistics is about data cleaning and getting data in the right shape. So we use all kinds of R packages for that. For example, tidyverse or dplyr. We have, of course, to assess missing data, for example, using R package Vim or Datamate. Checking the validity of the data, which is this presentation is about. So we have the package validate and validate tools. And I'm going to talk about Validate Suggest. And there are, of course, a couple of other packages which are useful for doing data cleaning. For example, error locate for finding errors and imputing values using, for example, again, Vim or recipes or simputation. These are all packages useful for making your data better. So if you look at the statistical value chain, so you can see what we do in official statistics in the grand scheme is that we collect data, which is raw data, and we improve this data until it is good enough for output. So one very important step is to check your data at what the quality of your data is. And this can be done not only at the editing phase, so when you're changing or improving your data, but also at the output phase. So most of our offices are part of the European statistical system or other systems, and we also provide data to other offices. For example, the Europeans deliver data to the Eurostat, and I'm sure the other countries in the world are also providing data to, for example, United Nations or other organizations. And you ideally would like to check this data when you move this to another office. So checking data can be done using rules. And we use in our packages the concept of validation rules. So for example, package validate allows to formulate explicit data rules that data must conform to. So making it explicit what the quality of the data is. So for example, if you have a data frame with age is 160 and driver's license is true, you can check if the age is above 16 years old and if age is in between 150 and 0. making these rules explicit helps to see if the data is correct or not. So these explicit validation rules give a clear overview what the data must conform to. It is an explicit data quality instrument. So if you share the same data validation rules, you can assure that you have a similar data quality. You can also use it to reason about, and you can use it to fix data. But yeah, it's mainly a tool to manage the data quality, to manage data quality, because data quality varies over time. As we all know that if you have been working a bit longer at an organization like a statistical office, you know that data changes in quality. So, for example, organizations change or people change within a statistical process, or systems change because the software is not up to date anymore, or there's a new method used. So you would like to check if the quality still meets your standards. And data validation rules helps to formulate the explicit data quality. So this makes sure that there are no costly recalculations, retransmissions, or data ping pong or undetected errors. So the thing is, we need to validate data before it's used in other process steps or before it's published. So what is validate suggest? Well, because I just argued that validation should be as explicit as possible, for example, using rules. The thing is, how do you create a rule set? So typically, we use domain experts who know the data. So they make explicit data errors, or they make the possible errors explicit, and they build upon their knowledge of the data. Or we use existing production systems, in which often deep down there are all kinds of implicit rules for checking the data. So it's a bit of archaeology, software archaeology, finding out where the rules are hidden in this production system. But ideally, you would like to have just a clear rule set of what the data should be about, and what the data should conform to. So the idea of validate suggest is to bootstrap this process using the data. It's a bit of a chicken egg problem, of course, but we use the data to generate rule suggestions, which can be used to compile a set of rules. So we infer the rules from the data, starting with the clean or slightly dirty data set. So you start with a data set, and then validate suggest generates all kinds of rules which describe the shape of the data. And the reasoning is that more data and more knowledge generates better rules. And we also use generating these rule suggestions. We follow the typical rules for official statistics. So there are a couple of European there have been a couple of European ESS projects in which all kinds of validation frameworks are described. And also our validate package contains a cookbook, a validation cookbook, in which all kinds of typical rules are described that are typically used within official statistics. So from the giant universe of possible rules, we try to stick within the mostly used rules in official statistics. And the rule suggestions should be human readable, and the rule suggestions are suggestions, so you shouldn't use them immediately in the production system, but they are useful for developers and maintainers and should always be interpreted before used in production. So what the suggestions are is that within the validate, the validate suggest package, there are a couple of functions, and there are two types of functions. One type starts with the prefix suggest, So there is a function suggestion, the type of a variable, the range check, NA check, unique check, ratio check, and conditional rules. And I will explain a couple of them, not all. And there is one useful function doing it all, which is suggest all. So let's look at just a small example, very simple, but nonetheless, it's useful, especially when there's lots of variables. So let's suppose we load validate and validate suggests. We load dataset called retailers, which is a dataset within package validate. It's a package. It's a dataset with lots of errors and missing values. And we could do, for example, do a suggest type check, and then it will generate a validator object with all kinds of type checks for these variables. So using this data set. So each suggest function also has a write companion generating R code. So for example, if we use the write type check, we generate an R file, so it can write to an R text file, well, which can be executed, of course. So let's look at a more complicated one. Suggest ratio check. So it generates rule suggestions for the ratio of two variables. And it has a threshold for only selecting variables that are correlated enough. So for example, if we would execute suggest ratio check for retailers and we only select variables which are correlated above 0.95, then we would get this rule set showing the relationship between these two variables, so the upper and lower boundary of the ratio of these two variables, which is a typical thing happening in visual statistics, these ratio checks. Often these are sometimes growth things or whatever. Not a more complicated rule or complex rule is conditional rules. So there's a function called suggest cont rule, which generates the conditional rules for two variables. Uses a very simple machine learning technique called association rules. Also, a card version is in the works, using frequency counts of which combinations are available within the data. So, for example, if we look at the dataset car owner, which is included within the validate suggest package, and we generate a conditional rule for car owners, you would find that there are no records where, when the driver's license is false, a person doesn't own a car, which is generated from the suggestions that there are no records that have this combination. And if a person owns a car, then his or her income is more than zero, which is also generated from the records in the dataset. And if we execute suggest all, you get all things for car owners. So you can see if we do a write suggestion that an R file is generated, which can be loaded into validate with all checks, which can be checked by the domain expert. So the idea is to put this on CRAN. It's still in development phase, so you can check and install the package using GitHub. And I'm planning to upload it to CRAN or CRAN in 2 weeks' time. So I'm very open to your suggestions. One thing I didn't mention on the sheet is that we'll be looking into time series checks, which are not yet included in the package itself. So thank you for your attention.
Thank you, Edwin. Very interesting presentation. There are two questions that are connected, I think. The first one is, are there real-world examples for fields of statistics where validated suggest is currently used in CVS? But I guess it's not really used. But the second one is, it's congratulating on the validated R packages in general, and how is the domain expert's opinion on the AI-created rules? So basically, if they like it or not, or if they agree with the rules. Can you comment on that?
Yes, it's not used at this moment. It hasn't been used in this moment in production systems. So that's It's a very short answer, of course. We just are starting with experimenting with the domain experts. So what can I say? I don't have a clear answer yet. So I will have to get back on that. Yeah, sorry.
Okay, don't worry. Thank you for your answer. We are already quite far in advance. We will move on to the last presentation. Thank you, Edwin, again. The last presentation will be by a colleague from the Statistical Office of Poznan, Andre. I hope, I think you are already co-presenter. I can see you. Let's just check that you can also talk. We can hear you. Hello, are you there?
Hello. Hello.
Great.
All right. Thank you very much. Hello, everybody. I would like to present you some our experience concerning the use of our packages of the statistical disclosure control. Please, I will make the screen available. Please, one moment, please. Yes, here is my. Oh, okay. Okay, I hope that it is visible for you.
It's okay, yeah.
Yes. So, our presentation, which was prepared with Tomasz Józefowski and Tomasz Klimanek, will be focused on the problem of the statistical disclosure control. To say very shortly, the main problem of statistical disclosure control is to minimize the risk of disclosure of the sensitive information and simultaneous maximization of the utility of disclosure data for the users. What is equivalent to the minimization of the information loss resulted from the application of the statistical disclosure control methods. So it is it is necessary from the best understood interest of both of official statistics and of the user, especially from the scientific environment, society. And so available packages can be used to perform the whole statistical disclosure control, and of course they have many advantages and also some drawbacks. So I will present our observation resulting from our experience made during realization some methodological works and other project. So I will present the main utility criteria, and next I will present a short assessment of particular packages. First of all, the SDC table, SDC micro, record swapping, and Silky, and some other, which are key packages for conducting the statistical disclosure control. And at the end, the conclusions will be formulated. So as we know, the statistical disclosure control methods can be grouped into several categories, taking into account the main approach. We distinguish perturbative methods, and perturbative methods, and of course, different methods of SDC are used for tabular data, other for microdata, and also another for results of analysis and graphs and so on. So we have the basic outline of the SDC process from original data through the assessing the needs of protection, identify factors, classification of variables, choose methods and tools, primary assessment, use selected SDC tools, final assessment of disclosure risk and expected information loss, and prepare final data. It is worth to underline that the whole SDC process can be performed in the environment, but some steps of it are largely arbitrary. So, for instance, assessing the need to protect of confidentiality or classifying variables, taking into account how much sensitive information, but they can be quickly performed using our packages. The packages SDC micro and record swapping are dedicated for microdata, and SDC table and Silky for tabular data, and there are also packages for generating synthetic data. Of course, in R, one can write the custom SDC procedure as well. So the main criteria of assessment which we have used are availability of different SDC methods and applications. So we have assessed which various SDC tools is offered, or at least if the package is focused on the specific solution, and we have assessed whether all operations are performed on the same type of object and using the same data format throughout the whole process. The second criterion was the availability of methods for assessing disclosure risk. That is, we have assumed that the efficient software should provide reliable tools for assessing the disclosure risk, or at least should be easy to use with other packages which offer such possibilities. Available measures of risk should be suited to various classes of data and variables, and implement the key rules of confidentiality. And it should be possible to compute disclosure risk at each stage of the SDC process. It is very important to enable controlling the process at each stage, each step of it. Next criterion was the availability of methods for assessing information loss. That it is, we have assumed that the efficient software should provide reliable tools for assessing information loss resulting from the application of SDC methods, or at least should be easy to use with other packages which offer such possibilities. And of course, measures of information loss should be suited to various classes of data and variables, and should be very easy and clearly interpretable, especially in terms of total loss assessment and loss for particular variables, as the information of information loss is expected to be available for users, so it should be especially clear. And last criterion was the performance. That is, the efficiency of software should minimize computation time and ensure that even large files can be processed relatively quickly, and it should be make easy to apply measures of disclosure risk and information loss and restart the whole SDC process. And of course, it should enable the users to have full control over the entire SDC process. So the first package which was assessed was the SDC table. The function protect tables protect table enables several approaches. The same methods can be applied to secondary suppression. Sorry, it is not possible to quickly apply perturbative methods such as surrounding noise addition or controlled tabular adjustment. Although the an implementation of rounding or CTR was planned, but no information about it can be found in the current documentation of the package. As regards the methods for assessing disclosure risks, they are based on unsafe cells, which are defined using confidentiality rules included in the primary suppression function. That is the frequency rule with parameters max frequency and allow zeros, NK dominance rule, percent rule, and ratio P to Q rule with parameters P and Q. More rule customization options are only available for greater arduous input procedures. Unfortunately, there is no explanation what particular parameters mean. As regards the methods for assessing information loss, there is no inbuilt methods in enabling direct computation of distance between the original and safe table. But custom scripts can be obviously written, but the original and safe table would have to be converted to a data frame format with the same the structure. And the performance is roughly good, but there are problems with available memory and capacity of processor, especially for a compositor tables including 50 variables from the microdata set of not more than 100,000 records. Computation in this case have to be performed on subsets. Because the final table can be generated only after secondary suppression, the process cannot be stopped after primary suppression, which is a nuisance in practice. And it would be nice if it was be possible to convert the safe table to a traditional form, not only continuous. As regards the SDC micro,
just a short intervention.
Yes.
You have 2 more minutes.
Okay. The main advantage of the SDC micro from the point of view of the available SDC methods and tools is that all actions can be performed using the same object class. The save file can be exported to commonly used formats for instance Excel. Disadvantage is unclear how some parameter settings affect the process. The package offers several methods for assessing disclosure risk, but separate for categorical variables and separate for continuous variables, so there is no complex method. The problem is there is some problem that the use of individual risk and measure risk can give different results, and here we have the explanation what is it. As regards the methods for assessing information loss, so we have two primary methods, I1 and difference of eigenvalues, but they have their drawbacks. For instance, the I1 is sensitive for small standard estimation and can lead for overestimation of the information loss, and in difference of eigenvalues there is the problem of data gaps. So last time we have proposed other methods based on the comparison of the original data set in the final data set after the SDC. So we have these methods, especially the method IL variables, takes all the measurement scales into account, and the IL correl is based on the inverse correlation metrics for continuous variables and assess the loss on the connections between variables. The performance is rather good, although for the largest variables there are some problems. As the package record swapping is focused for on one method, targeted record swapping. The methods of disclosure risk are used only internally. There is no methods of assessing information loss, and the main problem of performance is that the processes data must be integers, so they need to be transformed and then retransformed for further use. So what it causes problems for continuous variables and in the computation of total risk and information loss. And there are some also minor problems with the interaction with SDC micro. Also, the Silky is focused on the Silky methods. It has no methods for assessing of disclosure risks, and three basic methods for assessing information loss based on the distance between original and masked or perturbed values. And there is consistency with consistency with SDC table and also some other packages. The package is still not in current, but only on GitHub. And next, the package for synthetic data. They have SynPop mice and SynPop. They have a wide collection for synthesization methods. There is here known method for assessing disclosure risk. Although in some packages, some procedures compute it internally. There is no method for assessing information loss, and the main drawback is that these packages are not harmonized with SDC micro as regards assessing efficiency and the quality of synthesization from the point of view of SDC. And the main conclusion are that there are several useful packages for SDC offering a variety of tools dedicated to specific methods. They are generally efficient, although not sufficiently for large data sets. There is a little harmonization between various SDC packages regarding the same type of data, but still it is usually impossible to conduct the whole SDC process on the same object type. For this reason, it is difficult or impossible to keep track of steps and assess changes regarding the disclosure risk and information loss. And with the exception of tools for assessing information loss in SDC micro, there is no tool for evaluating the disclosure risk and information loss, which jointly accounts for risk in categorical and continuous variables. Some packages do not even have such measures. And of course, a tool enabling a quick evaluation of external risk resulting from the use of other data sources by simulation would be also desirable. So I apologize for small delay, but I hope that my conclusion will be useful for next developing of these packages. Thank you very much for your attention.
Thank you very much for the thorough overview of the SDC methods available in R and the comments on them. Given the time, I think we should move to the break to give at least some time for a convenience break before we come back at 5 o'clock. If you look at the Slido, right now I see one question that is directed to you, and you can also reply directly in Slido if you would do so, please. Thank you to all three presenters. We will move away. We will break for 6 minutes until 5 o'clock sharp to start off with the next session. Thank you.
Thank you.
Hello again, everybody. I'll be replacing Bogdan Wancha as chair of this session regarding time series and longitudinal data analysis. I've also I'll put in the general chat the link to the Slido website application in order to put your questions there. So in this session, we'll have two presentations regarding seasonal adjustment and one presentation regarding vocational training and impact on enterprises. So time being of the essence, without further ado, I'll give the floor to Alain Quartier-Latin from Statistics Canada to present us the interplay between R and JDemetra Plus. Alain, the floor is yours. Thank you.
Hello, everyone. I hope you hear me.
Yes, we can hear you.
Okay, perfect. So I'm Alain Cartier-Latin from the INSEE, not Statistics Canada, but not a problem. And I will talk about some R packages around the software called JDemetra. So first, what is JDemetra? JDemetra is an open source software officially recommended by Eurostat for seasonal adjustment. It implements the two-leading seasonal adjustment method called X14 and Primosit with some nice and friendly graphical interface. Well, in CRAN, you already have R packages called RGDemetra, which is an R interface to JDemetra. And well, not that this is the only package that enables to use the Primosit method, and that it's faster than the other existing packages, and it also allows to deal with some objects that can be used if you do seasonal adjustment in production. So in R, you also have some other packages to do seasonal adjustment. For example, to do the SCL decomposition, you can use those functions, but not that for official statistics. STL is not recommended because you cannot perform calendar adjustment. And you also have two other packages, seasonal and X12, that are interfaced to the US Census Bureau binaries. So this is different to JDemetra, but the same method. But in those packages, you cannot use Primosit. And now there is a current development of a new version of JDemetra. And with this new version, will come several R packages, and not only around seasonal adjustment, but around time series analysis. And the goal of my presentation is to give you an overview of the different packages. So not that you need Java to use all the R packages, but you can easily install a portable version. Just follow the installation manual. All the packages are in GitHub, so you can already install and use them. So here it just a simplified diagram of the links between the different packages, but not that it might change in the future. So some of them might be merged or splitted. So I will first talk about some utility package, then present the seasonal adjustment new package, and then briefly talk about the other packages. Well, the first one is called RGD3 Toolkit. It enables to mainly to do some tests around the data, for example, normality tests, sometimes with more parameters than the available function in R. Sometimes in my presentation, there is a bold light. It means that this function is new to the R environment, so I didn't find any equivalent in another R package that is in CRAN. So here, this is, for example, the case of some specific test to test the randomness of data. you also have some other function, but we'll go quick. The second package is called RGD3 modeling. So it brings a lot of new things to the R environment. First, you can create a user-defined calendar and trading days regressors. It allows you to perform trading days adjustment, but with some variable that will be specific to your country. So, for example, you will take into account the different holidays, so Easter, Christmas, or other days. You also have some function to create different kind of outliers that can be used in any other model. You also have some specific tests, but I won't go into details. You also have some function to manipulate ARIMA models. So some complicated things like decomposition, but also some simple things like estimation. Also some function to stationarize your time series, and several specification function if you want to create a user-defined specification for seasonal adjustment. So here you just have an example on how to create a specific calendar. So you just create a calendar, you specify the different holidays. So here it's an example with France. And then while you can easily extract the different days of the holidays. So here it's Christmas, New Year, for example. And you have also some other function to create some regressors that then can be used to model the trading days effect in your linear regression or your ARIMA models. And here is just an example on how to create some also some outliers regressors. And while I talk about ARIMA estimation, so you can already do it in base R, but not that with those functions, you can do it faster, so more than 20 times faster. But for the moment, the interface is less friendly than the base R interface. Well, the next package is mostly around some tests on the presence of seasonality. So if you don't know the test, well, you can skip this package. Here's just an example. I will talk now about the different seasonal adjustment package. The first one, you might not use it because it's only devoted to the formatting of the output. And while between the different packages, you have some function to set your specification. So, for example, if you want to add some specific outliers to your model, or to remove the trading days effect, or to add an Easter effect, there. And then you have, well, two packages, RGD3 X13 for the X13 method and RGD3 Tramosit for the Tramosit method. Where you can create your specification, apply your model with the corresponding function. Well, you can also, if you don't need to do a full seasonal adjustment, you can only use the first step of the seasonal adjustment, which is RegARIMA modeling. So if you just want to do a really fast RegARIMA modeling with some outlier correction, trading days adjustment, you can directly use those functions. You have also some refresh function in that. Well, the goal is to answer to the question of how you refresh your model when you have new data. Well, here is just a quick comparison of the time between the different packages. So in here with the concurrent seasonal, well, with RGDMetra, the presentation is already 3 times faster, the computation, but now with the new packages, you are more than 12 times faster than the main concurrent. So this is really huge. Well, here just a quick example. While you have already some nice output in R, you have also some plot and some summary function to plot the result of your data. And the same idea with the Chromosits package. Well, you have also an GDemetra 3 package, but it's more for the GDemetra users. It will include some function to manipulate some objects called workspace that can be used when in production. Well, you have also some packages for seasonal adjustment of high frequency data. So if you are interested, just wait 10 minutes and follow the presentation of Anna. And now I'll briefly talk about the other packages. Well, the first one, the idea is just to easily do some seasonal adjustment with ggplot. So here I just put data, I perform directly a seasonal adjustment to plot the forecast of my input time series, the seasonal adjustment, and the forecast of the seasonal adjustment. And I add some information about the detected outliers. And well, here there's a little bug, but I will correct it. But the plot should be nicer than this one. And you have also some autoplot functions to directly plot the models. Well, now, this is my favorite package because it really allows to manipulate some object called moving average, but don't have time to go into details. So the goal is to manipulate those kind of object, and with this package you can easily create, combine, apply all kind of appliers. You have also lots of complicated but very interesting things about trend cycle estimates on this package. And if you are interested, see another presentation I did in another conference. Well, you have also some packages around time series or modeling on a state space model. So it's really simple to use, and around benchmarking also. So, well, to conclude, now you will have lots of new things with this new version of this software, not only on time series. So this presentation was really quick, but I just wanted to give you an overview of the new possibilities that you will be able to have. So if you are interested or if you have questions, well, you can reach us on GitHub or on whatever you want. Thank you for your attention.
Thank you for your presentation. Quite impressive work. On Slido, I don't see any questions right now, but I have a question for you if you can answer. Did you re-implement some of the backend, or these packages are wrappers around GDemetra?
Yes, indeed. Well, the goal of the package is not to re-implement the method, but to use the same algorithm that are used in GDemetra. So here there are just wrappers of the main core software.
Yeah, because I've seen that comparison with the other package and improvements regarding.
Well, yes, because between the GDemetra and the new package, there is a change of technology on how to interact with the software.
Okay, thank you. So we'll go to the next presentation regarding also seasonal adjustment on infra-monthly time series, or also with GDemetra Plus. So Anna Smith from INSEE France, please, you have the floor.
So hello, I hope you hear me. So my name is Anna Smik, as you said, and so thank you, Alain, for his presentation, because I will be conveniently focusing on a small part of the huge scope you described, and we'll be talking about. Do you see my screen?
Oh, no.
Well, sorry for this. I guess this one works.
Yes, now.
Yeah,
Okay.
well, sorry. Well, that's this one. Okay. Okay.
Great.
So
Okay.
yes. So we'll be focusing on seasonal adjustment of high frequency data, and it's benefiting from a joint work I did with Carsten Webel from the Deutsche Bundesbank. And so here is the outline of my presentation. So just a quick reminder of seasonal adjustment in a general case, and then we'll get into characteristics of high frequency data and see how the existing algorithms need to be modified to deal with such challenges. And then we'll see some quality assessment possibilities and conclude. So high frequency data is referring to time series with a frequency higher than monthly. It could be weekly, daily, hourly, or whatever. It could be every 2 hours, every half an hour, quarter of an hour. So we will be trying to deal with this. And maybe you noticed, especially since the COVID pandemic, this data become more and more ubiquitous in official statistics. And very often they are seasonal and thus require seasonal adjustment for interpretation. So the goal of my presentation is to show how seasonal adjustment algorithms which were developed for monthly or quarterly series had to be modified in GeoDemetra Plus to deal with high frequency data. And for this, we'll be using RGD3 HighFreg, our package. So just quickly, goal of seasonal adjustment is to remove from the series any infra-yearly periodic movements. So here, the reference period is still the year, and it requires estimating seasonal and calendar factors, which will then be subtracted for the rows from the row series in an additive models, and will be dividing the row series in a multiplicative model. So here, due to time limitation, I'll skip the calendar adjustment altogether, which is a very rich issue, especially with high frequency data. And so for this estimation, anyway, we have to split the data, so to do decompositions to identify a seasonal factor. And as Alain told you, 2 algorithms are very widely used in official statistics to do this, namely X13 ARIMA and Tramosits. So what are the characteristics of high frequency data? So let's start with an example: daily French birth between 1968 and 2020. So the problem is that on such a plot, you don't see much. That's also a problem with high frequency data. You have to zoom your plots. And here, if you zoom on the last 2 years, you see a yearly periodicity of P equals to 365.25, which is the yearly periodicity, because you see that 1 year is like to the following year. And then if you try to break this by day of the week, you also see some periodicity, which will be highlighting a weekly periodicity, P equals 7. For example, you can notice that a bit surprisingly or not, the number of baby deliveries is really lower on Sundays. So then what we've seen through this example is that high frequency data can have multiple and non-integer periodicities. So here I sum it up in a table, and for a daily series, note that it might display 3 periodicities: a weekly one, P equals 7, which means that Mondays are alike and different from Sundays, that a day of the week, periodicity it's called in general, and intra-monthly periodicities with periodicity equals to 13.44. So it means, for example, that the last days of each month are different from the first one. So that's a day of the month pattern. And this one is much more rare than the weekly one, for example, in daily series. And it also has a yearly periodicity of P equals 365.25, which is also non-integer. And it means that from one year to another, for example, the 15th or Junes are alike, the summer days are alike, and it's called the day of the year pattern. So how can you identify the seasonal patterns? You can, for example, using GDemetra, you can perform a Canova-Hansen test, which is a spectral one. And so here for our French birth, you see a huge peak at periodicity P equals 7, and then a peak around the yearly periodicity. And so just like for any seasonal adjustment, you do a decomposition into unobservable components. So you will have all the usual components, but what will be different for high frequency data is that you will have multiple seasonal factors. And so your seasonal factors will be composed of the different periodicities of your data. And so the decomposition will be done iteratively, periodicity by periodicity, starting with the smallest one, which means the highest frequency. And this for two reasons, because highest frequencies usually display the biggest and most stable variations, and also because cycles of highest frequencies can mix up with lower ones. So let's see now how algorithms get modified to take this into account. So as we've seen, the challenge is to deal with multiple and non-integer periodicities. And roughly for this, you have two classes of solutions. You can round your periodicities, like it's done in STL, for example, and this might involve imputing data, which might mean, for example, setting all the months to 31 days and stuff like this. Or you can use approximation for fractional backshift powers. And this second solution is implemented in X13 ARIMA and Tramosits extensions available in GDemetra Plus. So let's start with the first step. We have in both algorithms a linearization step where we use an ARIMA model to remove deterministic effects like outliers and calendar effects. So for high frequency data, we will be restricted to using the most frequent and popular ARIMA model, which is an airline model, which I describe here. And so as we see, this model might contain several differentiation with a seasonal power, and S can be non-integer. So the solution which has been implemented is to write S as an integer and a real number between 0 and 1. So for weekly periodicity, it would be 52 plus 0.18. And then you can use a Taylor approximation of your backshift operator. So if we stick to modeling French daily birth series, where we have two periodicities, weekly and yearly, the model would be written like this. And with a non-integer yearly periodicity, you would have a weighted average of 365 and 366. So this, then you can implement it in using R and calling the GDemetra Plus core algorithms. So you use RGD3 high-freq package, you put in your series, and then you can set up some parameters. You have a full calendar correction which can be done. You also have automatic outlier detection, when you can detect additive outliers, level shift, wiggling outliers. Level shifts were not very credible for daily births. And so you can do a linearization which is as comprehensive as a classical one. And so then to do the decomposition, you can, for example, use X11, which is a decomposition module of X13 ARIMA. And so it takes as an input the linearized series and then decomposes it periodicity by periodicity. Its structure will stay the same as the classical function and requires though some modifications for tackling non-integer periodicities. So that's we'll be illustrating now. So the preliminary trend filter for removing seasonality has to be adapted for non-integer periodicities. So here I give you the heuristics. I won't go into the details, but if you check all this, for example, for P equals 12, we fall back on 2 times 12 moving average, and for the yearly periodicities, you have this weights and this weights here for the endpoints, and you can check that the sum of weights equals 1. So then you have also to modify the seasonality extraction filters. I'm running late, sorry. So for example, for the 3 times 3 filter, you will use the Taylor approximation for each backshift operator, which will allow you to avoid imputing data. And so if you write down this filter, it will look like this with weighted averages of each periodicity. And so then here you can implement this in R. First, you tackle the period equals 7, and then you will tackle your yearly periodicities 365.25. And so the summary of the process will be that first, as in classical seasonal adjustment, you linearize your series, but here with a fractional airline model. And you can also compute your calendar effects here, which I don't detail. And then you can decompose periodicity by periodicity and get you final seasonally adjusted series. So just to give you a hint, for PEGAL7, it's in black, and PEGAL365, it's in red. So you see that the seasonality here patterns are really evolving over the long period. And then you have the final trend and seasonally adjusted series. And you can also do the same treatment in seeds, which is an ARIMA model-based decompositions using the fractional airline model. So then, as in any seasonal adjustment process, you will have to check for residual seasonality. And here it's a bit more complicated than in a monthly or quarterly case, because, for example, ANOVA-based tests are hard to use when periodicity is non-integer. So here we use, again, the Canova-Hansen test, which is a spectral one. And if we put it to the same scale as before, we see that our daily French birth series is now clean. So as a conclusion, we'll just remind you that the main challenges when seasonally adjusting high frequency data are tackling multiple and non-integer periodicities, that Demetra Plus version 3.0 features several tailored algorithms to do the work. And there is still further research to be done, namely developing seasonality tests adapted to high frequency data, and also honing criteria for filter and parameter selection. Thank you for your attention. Sorry, I ran a bit late.
Thanks for presentation, quite technical on time series analysis. I have a question regarding, you can use arbitrary temporal resolutions, right? On this, not only weeks, months, and so forth.
Yeah, exactly. You could for example, extend it X11. You can do it or anything. You can do it on any periodicity of series. The problem is how you select your filters.
Yeah. Okay. Thanks. If there are any questions, I don't see right now. They will be available on Slido, but the link provided in the chat. Thanks. So now we move on to the final presentation regarding the impact of vocational training courses on economic activities of enterprises. The presenter is Marius Nicolae Jula from the Faculty of Business and Administration, University of Bucharest. Marius, if you are online, you have the floor. Thank you.
Yes, thank you. I'm just sharing my screen. Just a second. Okay, hope you see my screen. Can you confirm it?
Yes, we can see your screen. Thanks.
Okay, thank you. Thank you. So the presentation for this evening in Romania is about impact of main skills targeted by CVT courses on economic activities of enterprises. It's kind of a mixture about two subjects that I am very interested into, about training and about data analysis. So our presentation is about how the continuing vocational training courses influences the enterprise's economic activity. For that, we tested three types of indicators: production indicators, efficiency indicators, and development indicators. And this analysis was carried out for 29 European countries in the last 10 years. For this type of study, we used R to solve our econometric models, mainly using panel data, including time series and longitudinal data. The source of data was, for all the models, Eurostat, and the main data were related to main skills needed for the development of the enterprise by type of skill, percentages, and main skills targeted by companies providing these courses. And to have a more robust model, we used two indicators related to the rate of gross domestic product and index of the same gross domestic product. Here is the definition for this continuing vocational training. I'm not going into details, but I'm just saying that we started from the definition that defines this type of training. And these are the skills and competencies that we took into consideration in our models. We selected some skills that we considered to be most important for companies, and also the skills that are mostly likely to be found on company list of required skills. Starting with general IT skills, management and team working, and going to oral and written communication or numeracy skills. We tested first the impact on main skills needed for the development of the enterprise on economic activities on production indicators. And we selected as production indicators three indicators: turnover, production value, and value added at factor cost. The models that we created and analyzed are presented on this slide, and it is a panel model. And what I should emphasize, looking at the results, we can observe that a lot of skills that we took into consideration had indeed a positive impact on the turnover of the companies. More about the results, we concluded that the model resulted in positive fixed effects in this panel model, mainly on high developed countries, and negative fixed effects in the other countries. We also found that there are some skills that have no significant, statistically speaking, positive impact. Moving to the next indicator, production value, the model looks pretty much the same as the previous one. Also, the positive impact skills were mainly the same, with the same conclusion that positive fixed effects were mainly recorded in the most developed countries in Europe. Not a general rule, but the results suggest this type of conclusion. The next indicator, value added at factor cost, shows some similar results with skills that have a positive impact on this indicator, with skills that have no significant positive impact value, and the separation between positive fixed effects and negative fixed effects, mainly as the other two indicators, with positive fixed effects on more developed countries. The next analysis was to test the impact on efficiency indicators. And as efficiency indicators, we selected turnover per person employed, apparent labor productivity, and gross operating surplus turnover. Looking at the results, also using panel data modeling, we have also determined that there are some skills with positive effects, and also in this type of model, we found out that there are more skills that have no statistically significant positive impact. Also, positive fixed effect is observed in more countries than in the previous three models. Moving to the next indicator, apparent labor productivity, the model looks similar with the previous one, with same division between positive fixed effects and negative fixed effects, mainly having positive fixed effects in most developed countries. The last indicator is about gross operating surplus turnover, with similar approach as the previous two. The last type of investment was related to test the impact on development indicators. And as development indicators, we selected growth rate of unemployment and investment per person employed. Here we have the results. We see also that positive fixed effects are in a lot more countries than in previous models. And the other model is somehow different, with a lot less positive fixed effects in most developed countries from Europe. As a conclusion, we made a summary of these selected skills and how they act regarding the impact to production efficiency and development. And as we can see here in this summary table, production indicators were more impacted by professional IT skills, management skills, team working skills, and so on. As a second conclusion, we found that the impact of this continuing vocational training have different impact on economic indicators. First, management skills, team working skills, and professional IT skills were positively correlated with all economic indicators. Office administration skills, foreign language skills, and numeracy and literacy skills have impact on all economic indicators, but not as much as the previous skills. And the last category have been mainly correlated with indicators of efficiency and development. We also tested the correlation between the needed skills as the companies suggested and the skills that are available on the market. And as we can see here, we have strong correlation values among these two indicators. And also we can see here there are some differences between median values of needed skills and skills that are provided by specialized companies in the market. As a conclusion regarding these findings, we can say that the percentage of enterprises that needed some skills for development is somehow greater than the percentage of enterprises providing the corresponding vocational training for a lot of skills. For example, general IT skills is a difference of more than 9%. For management skills, it's a need of more than 3%, and so on. There are also some skills that are covered pretty well with the offer from training companies, and we also have to mention that an aspect that is to be looked into about the size of the companies offering and the size of the companies that need this training. It's a follow-up development for this study. And thank you for your attention.
Thank you for your presentation. Quite interesting, this market of skill provisioning. I don't see right now any questions in the Slido website. I'll have a question. Did you think to include also the type of economic activity of the enterprises or sector to see if there is some type of link between these, or the enterprises were taken in general?
We can develop also the analysis including this type of parameter, but as I told you, I think the most important factor is to see we have the list of the companies divided by what training they require, and a list of companies with what skills they are providing, and to see if the size of the company, not exactly the sector, the size of the company is important, because, for example, if we say there are 3 companies that are requiring IT skills, but these 3 companies are having each 10 employees, and there is one company providing IT skills, but it's a company that is providing IT skills for thousands of students, potential students, there is no discrepancy between the offer and the demand. So this is the next step, to see if the size, the exact numbers, and I have to look into the available data to see if it's possible to improve the analysis.
Okay, thank you very much. I would like to thank all the presenters for the effort and for your great presentations, and also for the organizers who did a great job. Okay, I will resend in the chat access to the Slido website. So right now I'm gonna pass the chair to the next session chairman, Mark van der Loo from Statistics Netherlands, regarding R in production data analysis. Thank you. Have a nice evening.
Yes, thank you. And welcome everybody to the session on R in production with the theme, sub-theme data analysis. Before I introduce the first speaker, I just want to point out that we are in a new session. So that means we have a new Slido number. I will just share my screen so you can make a screenshot. So if you want to ask questions, I'm sorry, to any of the speakers, please go to slide.do and enter the number that you see here, 626-6980. And then we gather all the questions for this session over there. So I'll give everybody a second or two to make a screenshot so you don't forget the number. Okay. And you can also find that number in the PDF of the with the program. So our first speaker today comes from Statistics Iceland. Either Violeta should be there or Omar. Could you unmute yourself and start your video?
Yes, hello. Good evening.
Hi,
Do you hear me?
Violeta.
Yeah.
So
Hi.
our first speaker is Violeta Kalian from Stats Iceland. Nice to see you again. And she will be talking about population forecasting with Bayesian hierarchical models. The floor is yours.
Hi, I would try to share my screen. So I'm sharing the right thing. Okay, I think you are seeing now.
Yes.
Yes? Okay. Thank you for the invitation and presentation. And good evening or good morning to everybody and good afternoon. A very interesting conference until now, I must say. I didn't move from my chair at all since it started, and I took notes. So it was very good until now. I will be talking about our new attempt to population projections, I should say. I call it forecasting here, was a bit of abuse of language, but this is due to the fact that the components of the population predictions for the future values are done based on forecasting the in the more appropriate sense of the word. Why I'm saying that population predictions for the future should be called projections. Maybe many of you know, I don't know how many are into this kind of work, but that's because you don't use directly time series methods on the population as a whole, not to mention disaggregated by various factors, age, gender, citizenship, education, location in the country, or whatever. So one is not doing directly this, but it's doing this kind of process on the fertility, mortality, and migration processes, which are behind the population development. And with this, one uses then the so-called cohort component methods to put them together and predict what happens next year, starting with this year, and so on. We have a GitHub a link here, which is given. And maybe I should start discussing a bit more. So I will be explaining briefly what does it mean, what are the main problems we are confronted with, and what kind of solutions we have done and we have used until now, and we are using from now on, hopefully. And what are the difficulties that one meets, and especially the new demands. There are more and more demands from the users, either official or policymakers, but also the large audience, which wants more and more details about population in the future. And well, what are the methods and how we take advantage of R to analyze our data, to model fit, and to forecast based on these models? And what remains to be done, because we are not absolutely finished. And I will start with the first part. As I said, population predictions ideally should be done stochastically via cohort component method. So putting together all these processes that one predicts for migration, fertility, and mortality. I say stochastically because even if you have a good time series for your migration, forget about many dimensions, forget about details. One about fertility, one about mortality, combining these 3 time series together doesn't mean that if you put together a low, medium, and upper value, you will get the same for the population. So you need to simulate from these 3 processes many times and put together in many ways and get a large spectrum of possible paths for your population development. And from that spectrum, you find out the medium variant, let's say, in the more classical understanding of the word. And since I said this word variant, I must say that traditionally speaking, population projections are done based on assumptions, expert assumptions, with or without stochasticity added on those, or any kind of probability attached to those assumptions, or in some cases based on some modeling more or less extended. I will mention some details in a moment. So the problem that we are looking at is to estimate and predict population numbers in the presence of all kinds of issues, like small area population issues or rare events and even shocks. In the presence of the fact that we have strong expert opinions about what can happen or cannot happen. And this is not meaningless, and this is actually a very useful thing to use in a modern way. In the presence, of course, of uncertainty in all the parameters that we will ever determine by whatever model we would like to fit. And on top of that, errors in the data. And I mentioned here one very well known for many people who work with population data is deregistration errors, the fact that people leave the country and don't bother to go to the registers and announce this. So there is a overestimated population at any time in the registers. And also, of course, as a good statisticians, we want to report the uncertainty about our predictions or our estimates. Depends what we are doing. Are we just analyzing what we see, or we are trying to predict out of sample or in the sample. And so we say that, of course, solution must be based on modeling and combining information like these assumptions. And I call it prior information because that's the best word and it fits to the settings as well. So type of models until now, in recent years, here at Statistics Iceland, with totality in space, in time and age and by age. And so functional models work very well and still do work very well because these are very stable surfaces. And so this method consists both of smoothing the surface and then using an orthogonal expansion, and then using time series methods to predict the coefficients in the orthogonal expansions, which are dependent on time. So this is well done, and it's the so-called Hindman method. Everybody knows the demography package, probably the people who are in the field. And for migration, which is more problematic, we'll see a little more about that. This does not work very well. And then, of course, we had to do something more about it. We used autoregressive distributed lags for short-term migration, which took into account a lot of other factors like econometric or social indicators. These don't work on long term because we don't have predictions for these factors for long term, but only for short, which was pretty nice. The predictions for 5 years were very, very good, but one could not do this for 50 years. And for long and intermediate terms, there came all kinds of problems. We used some sort of decay models to model the emigration as a function of immigration, because we fitted that on the past data very well. And we used structural time series and Bayesian structural time series models for a longer term. So this was a very hybrid approach, but it worked well, to some quite okay. There are issues, and you will see what kind, which on top of the fact that there are more and more demands to what the projections should give, as I said, more details about it, pointed us to adopting new methods and doing all this modeling and predictions for all these processes in a more unified way, namely by using Bayesian models and hierarchical ones. And you will see a bit in a little while how they are built. This will, this will allow us to include complex correlation structures, of course, all kinds of characteristics that we might have data about: social, democratic, spatial, demographic, sorry, and economic even, and to incorporate qualitative information, quantitative information through priors. A very nice goal would be even to look into model averaging or ensemble modeling for this purpose. And we are not yet there, but we are doing some attempts on that. This is more the well-known things that you normally see on our previous population projections, the mortality rates or the fertility rates model. And this is what the migration looks like. And you see here, for example, only the total migration, how volatile time series they are. These are on the totals, especially due to foreign migration, which has big fluctuations depending on the economy. And we had boom after boom, unlike the Icelandic migration, which you see is much more stable. But for the foreigners, this creates big problems for predictions, especially on this way up. Very nice on the way down. But on the way up, there are big issues, not to mention the fact that in these years of big economic booms and big shocks in migration, the disparity between the genders is very, very high. So this adds to errors or the problems about predicting how to, quotation marks, get rid of some excesses like that. And what is the situation at this point? So in the past, as I said, we we treated migration giving two disjoint sort of predictions for the short term, as I said, or very detailed models, and the long term. And in the recent years, we even needed an intermediate term to connect these two very different regimes. So this was a very problematic also for the users to give interpretations to. But a very nice task was mortality and fertility that was done with unique models, as I say, functional models. The only problem is that for all these things, we did the projections only by time and age and, of course, gender, but no other more detailed structure. The new models allow for including for local predictions, and we used all this difficulty, all the things that looked like difficulties before we try to treat them as strengths for our new approach, in the sense that, well, we borrow strength around between the classes or cross-classified small categories with small numbers and small counts. The exceptions are continuing to exist. Shocks of any kind, we're not trying to predict. I mean, if there is a natural disaster, hope not. We are not trying that. And this is how the models are. The new models. I didn't want to write very complicated formulas for you, but I wrote the general idea. And the general idea says that, okay, we have a response, which is y. We model the probability of this response as a function of parameters. If we want, if we want some parametric models, but you will see it's not a unique choice. And that probability will depend on a set of other variables or characteristics, like, as I said, education, a region, a municipality, citizenship, or whatever characteristics. On the other hand, things are not stopping here. These parameters, now you have a choice. You can try to immediately determine them directly, but they might depend, you might model them as being distributed according to another law, which depends maybe on some second layer of parameters. And this given as a function of new parameters and maybe some other variables that you might observe. And you can continue like that. When do you stop? When you want to declare being a frequentist that you want to do a maximum likelihood, or you want to put some priors on your parameters and find out the posterior distributions of those if you are a Bayesian. And we did both of these approaches for different purposes. And all this model, as I say here, is hierarchical and multi-level, not only because it's a hierarchical in the sense of modelings or this kind of layer, not only that the structure of the groups observed in the population might be hierarchical, I mean the total and the municipalities or regions, but in the sense of the modeling, because you want to capture in the various levels the correlations which exist between observations belonging to similar people or similar groups, which share location, which share gender, which share age, and so on. So you want to capture all of this. And on the one more thing that appears is that the response might be individual or aggregated, and we had a very good time looking at it in modeling individual responses, like yes or no, this person dies or not dies, or events, or there is a birth or there is a migration event as a function of lots and lots of nice characteristics. If you have such data, and an official statistics place does, and try to find out what matters for these various events. Or you look at aggregated response. That's a more available data, even possible to use for the outside audience from the open data. When you have counts about groups that how many people of this age or this gender or this education do this or that event.
Violeta, you have about a minute left.
Oh my God. Okay, thank you. And yeah, in addition to this, there is one more issue, as I said, the fact that we are looking at time series. So our observations and then so the predictions that we want to make are also ordered through time and correlated and autocorrelated. So the structure is very complex. Fortunately, there are R packages which can help us to do to solve, to model and predict. And I mentioned these two of them that we use. BRMS, which is a stand running R package, very, very good, but takes more time. Faster packages, MG-CV, which use Laplace approximation for Bayesian inference, and so it's faster. So you can do both things to tune your model and do a BRMS as a more. And here is our types of models for counts and rates or for microdata. Very briefly described, and where we include either smooths, so you can do a generalized modeling, non-linear even, and use smooths or tensor product types of structures, and even Gaussian processes, which we like a lot because you can capture immediately age and time interplay in a nice way and in a basically non-parametric predictions for the unknown functions, which I called here F for the rates of these events. And one, as I said, can do lots of tests on the data. And here is a few beautiful pictures about our fitting model, and then the fact that you see how for example, the migration peaks at young ages, and then the kids of these migrants, and the fertility, of course, peaks at some other ages, the mortality in a different way. We checked for significance, as I said, on individual data, how the education plays or not plays a role, and how the type of family that the person is part of plays a role in fertility. If the municipality matters, and it does, not so much for deaths, but fertility and migration especially. And for the future, yeah, we are not yet combining, but we wrote a lot of code about it. We are combining all these components into the stochastic population predictions, which are almost there. Tested a lot by component, but we have to test for the overall and the model averaging. And that's it. Then I can stop here. And I have some references. Everything, including these slides, are on the GitHub page that I mentioned here at the beginning. And I will update the code also for the last part. We didn't build a package or anything, but just share all our code about how we do the various testings. And yeah.
Thank you very much for a very interesting talk. I think because of time, we're going to move immediately to the next speaker.
I will go to the Slido. So if somebody has, it would be very nice if somebody has questions.
If you would stop your screen
stop share. Yeah. Sure.
Thank you again. Our next speaker is Olgun Aydin from the Gdansk University of Technology. And he will speak to us about an R package for calculating composite indicators.
Hello, everyone. Good evening, good afternoon, good morning. So it depends in which time region you have. All right, so can you see my screen and everything is fine, I hope? Okay, I suppose
yes, it's fine, it's
okay.
fine. Yeah.
All right, perfect. Okay, so today I will be talking about our new R package. So this is going to be hopefully my second official R package. So together with my colleagues from Gdansk University of Technology, Department of Statistics, who are Michał Piatrzek and Marta Gutczanecka. So we were actually considering how can we provide or offer some easy to use package or any type of environment to calculate composite indicators. Because when we are talking about composite indicators, so we are actually talking about multiple variables and putting them together and finding one kind of representative value at the end. And based on that, actually, we can rank the countries and all the other stuff can be done. But of course, there are some challenges. So today, actually, I will be talking about challenges and some literature review around composite indicators and also our approach. We also propose some approach, in terms of calculating composite indicators in an iteration. All right, so yeah, I was mentioning that composite indicators are actually commonly used for evaluating or ranking any type of economical indicators, countries, institutions, can be actually anything. And actually, simply like we are trying to create or generate a representative value based on multiple indicators. So then actually this representative value is used to simply make some decision, rank them, and so on and so forth. So it's actually straightforward, and there are also some challenges, some concerns around how to actually decide on the weights, for example, when you are creating your composite indicator. And there are, of course, very well-equipped researchers, and they have great expertise around the domain, and they know actually what type of indicators should be in, and so on and so forth. But there is actually some sort of a blockage in front of them. There is no kind of a solution which is providing them end-to-end solution. So in the meaning that, of course, there are a few packages and on MATLAB and on R, which simply allows you to make those calculations. But at the end of the day, you have to, again, look at some results, and based on that, you should decide on your next steps. But here we are trying to remove this roadblock in front of the domain experts and who really would like to calculate composite indicators, as I said. So they are very well equipped when it comes to economic knowledge, economic phenomena, but they might have some struggles in terms of understanding all the calculations, or like even they might understand, but they have to understand also different packages and different solutions. So we are proposing an R package. So this R package just requires like few parameters from the user, of course, data set as well. And it is allowing users also to decide on different calculation metrics based on that. And even the user can decide some toleration regarding optimization steps. So based on that, all of those calculations are happening automatically, and all the results are provided to the user. And so at the end of the day, user knows what happened at each step, how the weights change over the steps and over this optimization iterations, and how the final calculation looks like. And this is also giving a quite good traceability in terms of all the calculations. So then actually researchers, users can use this information and put those results straight away to their research studies or any other reports. So then because they can easily show how those steps look like and what were the calculated values on the way. And let's now maybe talk a little bit about composite indicators. So when it started, and let's just first take a look at the Galileo's words. So what Galileo said that count what is countable, measure what is measurable, and what is not measurable, make it measurable. So all the idea actually came from there, and simply making something measurable, and this is important, and also simply like creating some value which is representing maybe hundreds of indicators and hundreds of different combinations of the indicators. And there is also amazing interest and amazing research are happening around the composite indicators all over the time. Those are the statistics taken from the Scoops database, and so simply keywords were like composite index, composite indicator, composite indices. So there is a huge actually increase over the time, especially in 2020, and this difference here is visible actually pretty high, and it keeps increasing. Let's move on. And what is it? So let's take a look actually what researchers already said. So for example, according to Michael Power, and this is a belong to family of second order measurement numbers based on numbers, so or so-called meta measurement. According to OECD, it means that mathematical combinations of a set of indicators used to summarize complex or multidimensional issues. And OECD's definition is also very important because they provide some regulations, they provide some kind of guidance in terms of calculating those composite indicators, and institutions, official institutes, have to follow them. And even OECD has a handbook, which was published in 2008. This handbook provides all the guidance and all the regulations around how to construct composite indicators. But unfortunately, when we look at literature, when we look at also those calculated indicators, it turns out that not all of them actually are following the guidance or following the practices recommended by OECD. Of course, that's also very important to explain all the calculation steps in a clear way and for the sake of the transparency. And also few researchers just wrote some critiques around this, around the calculation or construction process of composite indicators. And the one thing is very much confused in composite indicators world, let's say, weights and importance. So we have to clearly understand, and we have to clearly simply distinguish weights and importance, because they are actually totally two different things. So when we talk about the sensitivity analysis for composite indicators and inconsistencies in how weights are interpreted as measures of importance, so that there is also like some issues, some challenges. Often importance of a given variable might result actually different correlation with other diagnostic variables. And in addition to that, some other problems might appear. For example, when composite indicator includes negatively correlated variables, it might actually point out a logical inconsistency in the measures. So yeah, weights are not equal to importance. So what to do? So how can we simply tackle this topics or tackle this challenge? We can reduce set of the variables in our data set, but it means that we are losing the diversity. We can change the aggregation procedure. I don't know. We can move away from arithmetic average and we can use geometric mean, for example. Or we can move the variable to another subpillar, or we can just pretend that everything is okay. So what is actually the common approach and in the literature when it comes to creating composite indicators? So first of all, we are creating a composite indicator. Simply, we can calculate arithmetic average, and then we are starting with that. So then we are calculating the sensitivity index for each variable in our calculation. Then we calculate also and how much each variable contributes to the composite indicator. So then we are actually calculating weights. Actually, we are solving an optimization problem, and here usually simplex-based methods are being used. And then we are calculating the weights, modifying the index based on those weights, and again calculate the sensitivity index. So till the moment that we are actually having equal SI, so sensitivity index. So we are actually proposing here a different approach, and we also included this approach in our package. So we also wanted to add here VIF calculation, so variance inflation factor, because at the end of the day, we are generating these composite indicators based on some variables. And so we thought that if there's multicollinearity between those variables, so we might actually unnecessarily keep some of those in the data set, and this might also mislead the calculation. So how our modification proposal looks like. So we are finding the variables whose normalized SI is lower than this desired SI, optimal SI, and then we are only focusing on those ones. So because they look like the, let's say, least significant ones for our calculations. So then we are removing those ones with the highest VIF value. So simply like we are just looking at the least significant variables, and then we are saying actually like this, all right, so you are actually not so significant, dear variables, and you have also very high VIF. So addition to your insignificance, you also have multicollinearity issue. So we would like to get rid of you. So we are simply like excluding them from our data set. And then we are repeating this procedure till the moment that we reach this equal SI. And so our package, which is called CompIndexR, have like 7 functions, but our main function is calc underscore CompIndex. So calc index function simply calculate composite indicators by excluding the least significant variable at each step. I'm sorry. And there are also supporting functions for calc comp index. So SI linear, so it calculates the sensitivity index. And we have optimizer function. It's using fmincon simplex methods to simply solve our optimization problem. And scaling function provides standardization or normalization techniques. So far, we are supporting min, max, and standardization in our package. And calc average is also simply providing different type of averages. At the moment, simple geometric and harmonic average, those are the available ones in our package. So we are also trying to provide some different possibilities to the researchers, to the users. So how actually this main function looks like? What are the arguments or parameters of that? So we have, of course, the data set, right? So I'm sorry about that. So this has to be a matrix. So then average type has to be passed by the user. So in that case, we wanted to go with simple, like arithmetic average, and scaling methods, in this case, min, max. And user is also here able to pass threshold for VIF. So ideally, VIF should be 1. You don't want to have any multicollinearity, but this is also a very deep topic. And then we wanted to offer possibility to the user to set up here some threshold. Let's say I would like to exclude those least significant variables if their VIF is higher than 4, for example. And then we also added here some tolerance, because it turned out that sometimes it's impossible to find exactly sharp equal SIs, sensitivity index. We here also wanted to propose a tolerance. So let's say I'm okay with 1% difference, but rather than losing many other indicators till the moment that I will get totally sharp equal SIs, I can actually sacrifice 1% difference between them. And when we actually look at the decimals, even we round them into like just using 3 digits, for example, like this difference even disappears. Yeah, I think already we talk about them, and the tolerance actually can be between 0 and 1, as you can imagine. So threshold for VIF, like ideally should be higher than 1, and so scaling method already mentioned that about this. So how the results looks like. So we are actually providing a list of lists. So inside of this list of lists, so we have lists and also some other sub lists. So what do we provide? We provide all of those sensitivity index calculations. So what happened? So what were the initial SIs? What happened at the 0 stage? What happened on the first? And how many iterations run for that? And how the weights look like? Because at each iteration we are calculating weights and using optimization. So we are solving optimization problem at each step, and we are like calculating those weights and how those weights look like when at the very beginning, how they look like and how they look like after excluding some variables. And then we can also here see with how many variables we started. For example, in this example, we started with 10 and we ended up with 3. We excluded 7 of those. And then here we can also see the variable names, if simply like column names, I'm sorry, not variables, the column names. And we can see simply like what was the final, let's say, kind of our input variables, and we are able to see here SI at the last step. So in this case, SI is very equal. This is what we want to have, and so they actually here we managed to get to the proper kind of SI even without paying attention to the tolerance and everything. And then it also provides us the composite indicators calculation based on the final set of variables, based on the final weights, and then it ranks everything, and then simply it allows us to provide also this calculation based on all of those competitions.
Well, good.
So
a minute. Okay.
Also, yeah, I'm wrapping up. Thank you. So yeah, we actually ended up with few kind of conclusions. So we recommend that it would be good to always, even though we are providing some package, of course, would be good to always pay attention to the robustness of the composite indicator. Also, it's very important to make proper diagnosis in terms of using the data set, making sure that the data source is trustable, and so on and so forth. So those are our set of references, and thank you for your attention. That's all from my end.
Thank you. I see there are 2 questions in the chat. Let me take one, and then you can answer maybe the other one in Slido. So the first question is, how frequently do you envision should we update comp indexer? Should you like recalculate the optimal combination of indicators in each period? So it's kind of, I think, a question how stable the combination is of the sub-indicators.
Oh, okay. I would say like it depends on the type of the indicators that you are dealing and also frequency of them. So I mean, some of them can be changing monthly, weekly, yearly, so every 2 months. I mean, it's of course always good to keep things up to date, right? So if new update came for like a release for some new indicators, would be good to also update the composite indicators based on that, because if we don't, if the composite indicators were, for example, what was calculated based on the some data points from last year, of course, it wouldn't reflect this year's variables, values, or importance. So that's actually, I think, important to pay attention and take into account.
Okay, thank you once again for a very interesting contribution. I'm sure going to try the package when it comes out. So our next speaker is Stefano Di Candia from the FAO from Italy, and he's going to talk about using R to implement indirect estimation approaches with an application to SDG indicator 5A.1. Are you there, Stefano? Let's see if he's co-host already.
Hi everyone.
Yes, hello.
Can you hear me? Okay, hello.
Floor is yours.
Yes. My colleague Raymond Shama will start the presentation. So I think he also needs to be able to turn on his microphone.
Hello, everyone. Can you hear me?
Yes.
Okay. I hope everyone can hear me well. So firstly, we would like to thank you for this opportunity. We're really glad to participate in this really interesting seminar. All the presentation we have assisted were really interesting. So I hope ours will be the same. So we're going to present an indirect estimation approach for SDG indicators by using the case study of the SDG indicator 501, indicator on equal tenure rights for women on agricultural land. So firstly, we would like to outline our presentation by looking at the overview. Then we will present the projector estimator and its implementation, and finally the conclusion. With the overview, we would like to present the SDG indicator 501 just briefly. The SDG indicator 501 is part of the broader goal 5 to achieve gender equality and empower all women and girls. And its sub-target 5A, as you can see, is currently under custodianship of FAO to be monitored and to advocate for it. The indicator 501 is divided in two sub-indicators. The 501A that look at the percentage of total agricultural population with ownership or secure rights over agricultural land by sex. With ownership or secure rights, we mean if someone has a formal documentation or alienation rights. Does the right to sell, the right to bequeath. After we will understand why this explanation is important. And the sub-indicator 501B that monitor the share of women in agricultural household with ownership or secure rights over agricultural land over the total individuals with ownership or secure rights. So with our presentation, we aim to present thus the use of R in statistical analysis to develop indirect methods to produce proxy estimates, more accurate proxy estimates through the use of the so-called projector estimator. So specifically, our study enables the use of R facilities and additional packages to integrate data from independent complex survey and estimate alternative and better proxy estimates for the SDG indicator 501. So in our case study, we will look at the Nigeria General Household Survey Panel 2019 with the acronym LSMS survey to produce indirect estimates of the SDG indicator 501 into the demographic and health survey 2018. That it has some various limitations with regards to the recommended methodology to estimate the indicator 501, while the SMS does follows the recommended methodology. So through the projector estimator, we will see how we can produce better accurate proxy estimates. Now let's just quickly see the differences between the two surveys, just to make you better understand why we have decided to have this work. So firstly, the DHS has age limitation for which it was not possible to identify our variable of interest for a whole population, but just as you can see, for a limited age population. While in the LSMS, it was actually possible. And the other main limitation of the DHS, it was the alienation rights were missing, while we do have the alienation rights in the LSMS. So we have decided to proceed and use the projector estimator. As you can see in the image, we consider two independent surveys, where the first survey, survey 1, it's our DHS, so the survey with the limitation already explained, that collects only variable of general use, so auxiliary variables. And for those auxiliary variables, there is not this problem of age limitation. While the second survey, it's our LSMS that collects information on our target variable, along with the same set of auxiliary variables available in the survey 1. The two samples, the DHS and SMS, but in general, the two samples may be selected from possible different frames in order to exploit distinct sampling designs. With this approach, a two-step process generates synthetic or proxy values of a variable of interest. So first, from the survey 2, we have the working model built through a logistic regression that link the variable of interest to the common auxiliary variables fitted on our data from our survey 2, leading to the estimation of a set of model parameters. Then, the second, the values of the variable of interest are predicted in survey 1 by applying the estimated parameters to the auxiliary variable observed in the other sample. That's just a brief explanation, and now my colleague Stefano Di Candia will better explain all the process. Thank you.
Thanks, Raymond. Therefore, we can move on to the steps and the packages used to integrate the two surveys and produce indirect estimates. First step is to identify and recode the common auxiliary variables. The implementation of the projection estimator requires the availability of the same set of auxiliary variables in the two surveys, and these variables need to share common structure and definitions. Basic R commands for recoding have been used for this task. The auxiliary variables that could be retrieved from both samples included a number of demographic and also social variables, such as gender, age, marital status, administrative level, etc. And this slide and the following provide information on this step of identification and recoding of the common variables. The second step is to select the variables to be included in the model, which I will say is one of the most important steps to ensure the quality of the results. The Boruta feature selection method implemented in the Boruta function of the Boruta package was used in this study. It is a wrapper method of feature selection built around the random forest classifier algorithm. In order to obtain a relative importance score of the predictors, dominance analysis was also applied to find the dominance of one predictor over another by comparing their additional contribution across all possible combinations of predictors in the model. And the domin function in the domir package computes dominance statistics for predictive modeling functions. The results of the feature selection step are presented in the graph on the left and in the table on the right. As you can see, the variable relationship with respect to the head of the household is by far the most important variable, followed by gender, age, state, which is an administrative level of Nigeria, marital status, while the scores of all the others variables are not displayed and were not used because they are less than 5%. They have a score less than 5%. So adding these variables to the model will not didn't lead to any substantial improvement. When choosing for the feature selection method, we opted for the Boruta algorithm, mainly for its fast implementation. The lasso or L1 regularization available in the GLMNet package could be a better choice, given its ability to select features that are useful, discarding the useless or redundant ones, leading to improvements in terms of both accuracy and also generalization. The third step is to define the function linking the variable of interest to the selected auxiliary variables, and to estimate the projection parameters. A weighted multinomial logistic regression is used to estimate the projection parameters, given that the dependent variable is binary, indicating whether or not the individual owns land. The survey package provides, among many other useful features for analysis of survey data, a function called SVYGM for fitting a generalized linear model to data from a survey design. Furthermore, to assess the performance of the model, distinguishing between the positive and negative classes of the dependent binary variable, the ROC curve was built using the function ROC of the package PROC. The resulting ROC curve led to an area under the curve equal to 0.83. In the final step, using the estimated projection parameters, synthetic values of the variable of interest in the DHS dataset are computed using the function predict, which in turn allow producing estimates of SDG indicator 5A1 using the package Regenesis. Now I leave again the floor to my colleague Raymond for the final part.
Thank you very much, Stefano. Just briefly, here are the results. The first row shows the estimates from the LSMS 2019. As you can see here, divided in all the sub-indicators of the SDG indicator 501. The second row are the estimates computed thanks to our projector estimator. And the third one are the estimates, the proxy estimates generated just through the DHS, in which again they had all the several limitations and need to look, for example, just on reported ownership instead of formal ownership, etc., etc. Again, in the DHS, we have as well used R to calibrate the different sex ratio due to some problems related to the DGS survey itself. But why we have done this work? Let's move on the conclusion. So we've done this work because there were lack of data for this particular indicator, and it can be used. It's a powerful method, a simple and powerful method that uses for sure different packages, but can be scale up to countries and give to everyone that want to impute indirect estimates in order to produce, for example, time series data points with respect, of course, to countries' law evolution. So on one side, it can be used to compare, for example, different SDG indicators. On the other side, it can be used to see how a new law in a country changed the previous estimates that could be retrieved through this indicator. For in this study, you could see how the percentage of women owners of agricultural land changed before and after a law, and that's it. In general, we wanted to show how it was. It can be used as a really powerful and simple tool to generate indirect estimates, accurate indirect estimates, and we hope other colleagues will be interested in doing so to compare different SDG indicators. Thank you very much from Stefano and Raymond for your attention.
Thank you. for a very interesting talk. It's always really nice to see that people are still putting effort in making these SDGs better and better. So, well, one obvious question I have is, are you planning or any to make any of your code available, so it would be easy for people to reuse it?
Yes, we are still working to implement, for example, as Stefano said before, the lasso methods in order to present both the Boruta and the lasso way to select auxiliary variables, and we will for sure present all of this in a paper along with the R code in order to let other countries reproduce, because that's why we are here.
Yes. Okay, thank you. And thank you also for keeping in time. So let's move on to the next presentation, which will be also a co-presentation, I believe, by Kitty Chen and Warsame Yusuf from respectively University of Ottawa and the Public Health Agency of Canada. And they will talk about CCHS flow, an open science approach to transform and combine population health datasets. Kitty and Warsame, the floor is yours.
Thank you. Thank you, Mark, for the introduction. My name is Warsame Yusuf. I'm an epidemiologist working with the Public Health Agency of Canada. My previous position, I was working at the Ottawa Hospital Research Institute with Dr. Doug Manuel, and it was during this time where CCHS flow was developed. So I'm just going to share my screen. Can you guys see the presentation?
Yes.
Perfect. So I will let Kitty, my colleague, begin the presentation if Kitty is ready.
Yes, good to go. All
Perfect.
right. So today we'll discuss about an R package that uses an open science approach to transform combined population data known as CCHS flow. To provide a bit more context to CCHS flow, we're going to give a background to CCHS, which is short for the Canadian Community Health Survey, look at the issues related to the CCHS cycles, and dive into the development and current status of CCHS flow. We'll also discuss the development and current status of an R package called Recode Flow that transform alternative data sources. So the CCHS is a population-based cross-sectional survey of Canadians that have been administered by Statistics Canada every 2 years since 2001. This survey contains information related to health status, healthcare utilization, and health determinants for the Canadian population. The CCHS is one of the largest and most robust ongoing raw population health surveys worldwide, with approximately 130,000 respondents per cycle. And this is available as a public use microdata file known as PUMP from 2001 to 2018. So working with large data sets comes with the issue of data cleaning for analysis. Data cleaning, including transforming variables into harmonized or common variables, is typically the most time-consuming part of data analysis. With the CCHS flow, data cleaning and harmonization issues arise when combining CCHS surveys due to changes in variable names and categories. So for example, in the age variable, if you're looking at the 2001 variable for age, this is named DHHA-GAGE with 15 categories, whereas in 2005, it is named DHHE-GAG with 16 categories. So these small changes can be troublesome over time. So the traditional method of data cleaning is hard coding data across cycles, and this involves writing scripts that recode individual variables. The problem with this is that it's labor intensive, prone to error, and if not done carefully, and there's no standardized method for recoding these variables. So when we discuss about open science approach, this is defined as a transparent and accessible knowledge that is shared and developed through collaborative networks. This includes sharing of data using public use data, such as the CCHS PUMP, using open source language such as R, and the sharing of code. So CCHS is an R package developed in 2019 by Warsami that transforms and harmonizes CCHS variables across survey cycles. Currently, it contains a repository of over 330 variables from 2001 to 2018 for the public use microdata file and the share files. It's available for installation through the comprehensive R archive network known as CRAN. CCHS flow can be used to transform individual variables such as BMI over one cycle or the entire survey cycle and provides metadata for each variable. The transformed datasets can then be combined to create a harmonized dataset across many years. So for example one, this is using only one variable for one survey cycle. And in example two, this transforms all the variables for the 2001 survey cycle. So within the CCHS flow package, there are specification worksheets, which include variable CSV, which specifies all the variables available in the package. Variable details provides information about each variable, including which cycle it's found, category structure, and etc. For processing variables, there is a reqwith table that recodes variables and survey cycles. Set data labels, which adds variables to transform variables and survey cycles, as well as merge rec data, which merges labels and labels transform survey cycles to create one data set. Derived variable functions are custom variables to generate these derived variables such as BMI. And there are also subsets of 200 respondents for each survey cycle to test the harmonization for variables. So this is available for the pump from 2001 to 2018, as well as the share files from 2009 to 2012. So now we'll go into a bit more detail about the content of the package. So variable CSV specifies all the variables available in CCHS flow and provides metadata for each variable. As shown on the left, this includes variable labels, variable type, subject and section, units, if applicable, and the description of the variable. Variable detail outlines the structure of each variable. It guides the transformation process by identifying survey cycles, the variables available, specifying the original and final variable names, specifying the original and final variable types from either categorical or continuous, and specifying the original and final category structures, such as original and final ranges for continuous variables. It provides additional metadata of each variable, along with the labels of categories. Notes are provided to identify potential issues when combining between survey cycles. So this is the variable detail CSV, as it provides extensive information on a variables from which cycle it's from, categorization, as well as its labels. reqwith table is one of the functions in CCHS flows that is used to transform variables for a given survey cycle. It uses information from the variable CSV and variable detail CSV to transform individual variables or an entire survey cycle using all available variables in this package. So the structure of reqwith table goes as follows. There is the data parameter, which specifies which data set to recode. Variable specifies which variable to recode. Variable detail specifies a variable detail sheets and function will recode. It will automatically recode the variable and variable detail from the package if not specified for variables and variable details. And lastly, there are notes that specifies if the note should be printed in the console during the recoding. Other processing functions include set data labels, which add labels to transform data using metadata from variables and variable details. There is merge rec data, which binds transform data together into one data set and adds labels to the final transform data set. So this example shows the recoding of the entire CCHS cycle for 2001 and 2012 using our subsetted data with using only 2 lines of code. The data set is then used to combined with the merge function to create a label data set. Along with the transforming existing CCHS variables, CCHS flow can be used to create derived variables. So simple derived variables can be created using variable details CSV. Complex variables require custom function, and complex variables require custom functions. It can be based on transformed CCHS variables, other derived variables, or both. On the right here is an example of a derived variable for adjusted BMI, and here we use the transformed CCHS variable to create this function.
So I'll be taking over for the rest of the presentation. So to stay true to the open science principles, CCHS flow is publicly available on GitHub. There are two ways users can contribute to the package. Users can clone the repository to the computer and submit changes via pull requests. Instructions on how to add variables can be found on the CCHS Flow website. As well, users can use the issue section of the GitHub repository to request variables to be added or to submit bug reports to help improve the package. So here's the front page of the CCHS Flow repository. Over here is how you would clone the repository to your machine. The top panel shows the issues section of the repository. Users can either submit a bug report or request a variable to be added to CCHS Flow. On the bottom panel, there are pull requests where users can request their changes to be merged into the main branch of GitHub repository. Now we'll discuss Recode Flow. So while CCHS Flow can be a powerful tool in transforming variables, it is restricted to data from the CCHS. Recode Flow was a package developed following CCHS Flow to transform and harmonize variables from other surveys and data sets. It uses the same transformation principles as CCHS Flow. It requires a variable sheet, a variable details sheet. It uses rec with table, set data labels, and it's also available for installation on CRAN. And so this is the website for Recode Flow. As well, users can contribute to the package on the GitHub repository for Recode Flow, just like you can with CCHS Flow. In summary, CCHS Flow is an open source package that transforms and harmonizes variables across numerous CCHS survey cycles. Instead of spending time recoding and transforming variables, Canadian health researchers can use CCHS Flow's existing library of variables to conduct longitudinal analyses. Specification worksheets are then used to guide the transformation process and provide metadata of transformed variables. The use of GitHub allows users to contribute to the package, allowing them to add variables that may be of value to other researchers. And as well, Recode Flow can now be used to transform variables from other surveys and data sets using the same transformation principles. Here are the references that we use for this presentation. And are there any questions?
Thank you for a very nice contribution. I think there was a question, but I think you just answered it, whether CCSH Flow's approach can be generalized to other data sources. But I think you just answered it with your package.
Something to note is that with CCHS Flow, the variables and variable details are already installed onto the package. With Recode Flow, users would have to generate their own variables and variable details for their own particular survey data set that they want to transform and harmonize. On the Recode Flow repository, there is a sample version of variables and variable details, just a very tester example where users can understand how to structure and guide these specification worksheets when transforming their own data sets.
Yeah. I was also wondering, because in the CCHS Flow, you make a choice, I guess, to which version of the variable you're going to recode everything. So you would like recode the 2001 variable to, like, say, the 2019 or something like that, to the, like, I guess, the latest version.
So this was
what if somebody wants to recode everything to the old definition for some reason? Is that possible? Is that included, or they have to do it themselves, or provide the variable sheet?
So if they want to transform it to a certain variable name, they can always suggest it in the issue section and provide feedback. We always want to hear from other researchers and other users on how to better improve the package. It's still in development. Kitty is now maintaining the package. So any suggestions on how to guide the variable structure is definitely welcome. When we were developing CCHS Flow back in 2019, what we noticed was that after 2007 onwards, Statistics Canada was using a more consistent variable name for the different survey cycles up until, say, 2015. So this represented about 6 to 7 survey cycles. So we decided as a team, we'll stick to this. This is the most common variable name, but it was an arbitrary decision. And if any researcher or any user has any suggestions on how to harmonize or standardize it for a newer version, they're more than welcome to provide feedback.
Okay, thank you very much once again. And I think it's time to move on to the last speaker of today. And I think Daphne Gisel of this, let me see, she's Director of Statistical Normativity of INEGI, that's Stats Mexico. And she will be talking about advantages of using R to enhance the analysis of women homicide in Mexico. Are you there, Daphne? Are you allowed to unmute? I think you have to still get the rights to unmute. I think Patrick will do that.
Could I just get the name again? Sorry.
That's Daphne Viramontes with an F, D-A-F-N-E.
It should be working now.
Hi.
Okay.
Do you hear me?
Yes.
Yes, we can hear you,
Okay.
and we can see you.
I have a little problem with the sound, but I'm very glad to be here and listen all the development and advances in using R in different files. Well, my presentation is called Advantage of Using R to Enhance the Analysis of Women Homicide in Mexico. Let me share the screen. Okay, what I like to focus on first is why to use R in the analysis of social phenomena. R has gained relevance in social science as a tool for data analysis. Its influence lies in the fact that it has been shown to improve the processing of large amount of data and has enabled operating databases more efficiently for the study of social phenomena. Despite of the gains in data analysis, applied R in social science has been limited. And this presentation looks to highlight the importance of using R in social science through the analysis of women homicide microdata. Like I said before, the presentation looks to present a practical application of R software in data analysis from a gender perspective. Okay, so moving on the methodology and data, I would like to present you some of the features of the database that I work. And the main idea that I use R programming to classify women homicide according to features related to violent deaths in different spaces. Well, the National Institute of Statistics and Geography, the Statistical Office in Mexico, published registered deaths for general mortality. The statistics of registered deaths have the purpose to generate and disseminate information on the phenomenon of mortality in the country, which make it possible to know and compare the volume, trends, characteristic of mortality in different geographical scopes of the countries. And it helps to inform the public health programs. These are the general death variables and are classified in 3 groups. The first one are those related to death, for example, registration date, death date, certification date, place of occurrence, healthcare status, cause of death, occurrence of time. The second one are those related to violence and violent deaths, presumption of accident, homicide, occurrence of job performance, also sites where the injury occurred, for example, housing units, sport areas, schools or streets or highways. These characteristics we can see in the database. Also, it shows characteristics about family violence status and relationship of the alleged aggressor. And the third one are related to the disease, for example, gender, age, schooling level, affiliation to health services, birth date, marital status, nationality, occupation, activity status. As you can see, these databases are very complete, and it helps us to classify violent deaths of women more precisely. To analyze database, we follow in the next steps. Firstly, we process the database to select those deaths related to violent deaths using the criteria established by the International Statistic Classification of Diseases. After that, we merge the databases for multiple years. It's important to mention that the analysis covered from 2000 to 2020. And thirdly, we construct a series of categorical variables for classifying female homicides according to violence, family violence status, the case of death, and relationship of the alleged aggressor. Finally, we select violent deaths, dividing them according to the site where the injury occurs, for example, in housing units or streets and highways. Well, figure 2 shows the trends in female homicide rate from 2000 to 2020 in Mexico, is the national level. And the curves represent the levels of the female homicide rate across the time and are divided according to the site of injury. And the blue curve represents homicides on housing units, and the red curve represents the homicide on streets and highways. In this point, is worth mentioning that this graph is the result of the processing of database using R, and it was made using ggplot2. As you can see in the graph, from 2000 to 2006, trends in women homicide are similar, but from 2007, there is a significant change in the trends between both lines. We can see that female homicide rate increased from 2007 onwards, and the gap between them got larger in the last years. Using R also facilitate us to analyze the female homicide rate across states, and we were able to identify which states had similar patterns of violence and which states had the most high rates of women homicide for the period that we are analyzing. Well, in summary, the analysis allows us to approach to identify the main factors involved in women homicide in Mexico. The results of the analysis shows that violent women homicide is greater in public space, for example, in streets and highways, than in private space, housing units. The analysis also showed that trends between women homicide in public and private spaces are similar, but there are certain periods in which gaps become broader. For discussion, R allow us to perform a more efficient analysis on female homicide. We use core tidyverse packages, for example, ggplot, dplyr, tidyr, reader,
table, etc. We don't develop any package additionally. And the time spent on classification and construction of variables has a considerable reduction in comparison with other software. It's important that further application of social data analysis need to be done, and this needs to develop metrics for different software apps. I think it's all of the presentation. Thank you very much for your attention.
Thank you very much, Daphne, for an interesting presentation. I see there are no questions currently in the Slido, but I have a question. There was indeed a striking periods where there was a gap between the that's in a housing situation and on the streets. And do you have any idea why those gaps occur in those times?
Yes, there is the principal. Well, we think it happens because in Mexico the war on drugs starts in 2006, and like you see in the graph, these have an impact on woman homicide on the streets, but not in housing units. And this conducted us to analyze how these kind of public policies can affect women, violence against women.
Okay, thank you. So there's a clear reason there. Okay, thank you once again for this very nice talk, which I feel really emphasizes once again how important official statistics can be. So I want to thank all the speakers again. We are closing the session for now. I also would like to thank Patrick for the technical support and giving everybody the co-host rights on time. And I think we are having a break now, and we'll be back at in 1 hour for the keynote session of Julia Silgi. Is that correct? No, there's another scientific session now. I'm very sorry. I was looking at the old program. The session is taken over now by Kiprian.
Hi, Mark. Hi, everybody. So welcome to this very nice conference. I'm very exciting. I'm in this conference involved from the beginning. So it's very nice to have you all here. There are almost 300 participants online today, but I am sure that will be more than 300 next 2 days. So now we have a session also very interesting from the perspective of official statistics. We have a session of survey sampling and estimation. So I will invite now the first speaker with the presentation of two-stage sampling design and sample selection with the R package R2Bit. So we have in this presentation 4 contributors: Giuliano Barcaroli from Italy, Andrea Fassuro, Alessio Gondalini, and Marco Terribili, all last three from ISTAT, from Italy. So I think they are ready to present, and I think Andrea Fasulo will be the presenter. Yes?
Yes.
So welcome to our conference.
Thank you very much.
Yeah, and the floor is yours.
Okay.
You'll present also with somebody else, or
no,
only
I'm
you?
alone.
Good, good. So good luck. I remember to all the participants from this session, you will have around 15 minutes. Yes? Okay.
Perfect. Thank you.
Okay,
Thank
good
you,
luck.
Sylvian. I'm going to share my screen. Okay. So again, thank you very much, Cyprian, and good evening, good afternoon, or good morning, wherever you are around the world. My name is Andrea Fasulo, and this evening I'm going to present you this joint work made with my former colleague Giulio Barcaroli and with my colleagues Alessio Guandalini and Marco Terribili. The presentation focus on an R package that we have developed together called R2Bit. R2Bit stands for R to Battle Extended Allocation for 2-stage, and implement the extension of Niemann and Chuprov optimal allocation methods, adapting generalization, two generalization. The first one presented by Bettel in 1989, and the second one presented by Falorzi in 1998. This extension allowed to determine the optimal sample allocation in multivariate and multi-domain case for two-stage stratified sample. And the last version of the packages provide also the resulting selection for both the stage, so for the PSUs and SSUs. The current version that you can find on CRAN is the version 1.0.4. There are several functions among the main function that derive the optimal allocation for two-stage. Here I just select a subsample of the function. So the first two help user to produce the input that we would see later on to carry out the allocation. But one stage basically allow to produce optimal allocation also for one stage sample design. And the last two are, as I said, function that allow to select the first stage and the second stage unit, so the PSU and the SSU. So this presentation focused on the bet.2st function. So the function that allow to derive optimal allocation using two-stage sample design. So this is the structure of the function. Also here, I select just the main parameter. There are also other tuning parameter that have some default value, but important. But here we have the most important. The first five are five data frame. I have no time to show these input in details, but I'm just going to tell you something about that. So Stratif is the first one. It's a data frame of survey data. So basically collect information about the variables that we are going to use to derive optimal allocation among with the standard deviation, the domains, and of course the strata identifier. The errors, so what are the errors that we want, that are planned, that we want to respect and found the optimal location. Des5, that is another data frame that contain a sampling design information about variables as the measure of sites of the strata, the sites of the SSU in the strata, and the minimum number of SSU that we want to collect in each PSUs. PSU file is another file, another data frame that contains information on the PSU, so information about the sites, the strata, and the ID, of course. And the last one is the raw data frame. That is a data frame containing information about the intra-class correlation coefficients, so information for all the variables that we are going to use for the allocation among divided by self-representative or non-self-representative PSUs. Here, there's also other important parameter as mean PSU strat, that allow us to set the minimum number of PSUs that we want to collect to draw in each strata, and mean nums strat, that is the minimum number of elementary units that we want to draw in each strata. This is the general framework of the function. So basically, we saw the input. Very easy way to derive the input is using Regenesis. That is another packages developed by another colleague of us, Diego Zardetto. And after that, we can run bit.toStage. That is basically a loop where we have a first step when we draw allocation using the bet1 stage, and this allocation will followed by will be used to select to determine the self-representative and non-self-representative PSUs, update the depth, and update the population variance. These will be the new input of the function that will carry out another allocation, and so on until the convergence. After that, we can select the primary stage unit, and after that, the secondary stage unit. This function will return us a list containing 8 objects. Again, I have no time to show you all the output of the function, but of course, what we have is the allocation. The function provides the optimal allocation among with the uniform and proportional allocation. Very nice, the expected. That means the expected CV error that we will have using this optimal allocation. And another very nice output is sensitivity. Sensitivity is an output that allows us to understand the stronger leverage to manage, to change our sample size. So basically give us information about how the expected sample size will change, changing the CV of 10%. Okay, now I briefly show you our case studies using the packages. There are 2 possible scenarios in which we can work using these packages. A first scenario when also a sampling frame is available, so we have no about information from previous service occasion, or a second scenario when where we have both sampling frame and another survey occasion, a previous sample service occasion. Of course, the first scenario is a stricter condition scenario in which we need more information for all the unit in the sampling frame about the target variable or a proxy target variable that we can use to derive the optimal allocation. This case study is an application under the second scenario, and is a scenario, an application that is basically divided in 3 steps. First step when we can prepare the input. Second step, we can derive the optimal allocation, and the third step, we can select our units, primary and secondary. The case study works using a population data frame of about 2,258,000 units, using social demographic information in detail, the occupational status, 4 modes of the occupational status, and the total income. So the first function that we are going to use is prepare input to allocation 1 that create the input to bet.2st, among with some graph that allow us to manage a little bit the input. So in the second step, we are going to run bet.2st. What we miss is just the last input that are the error, the CD. So we can provide CD here in this example. As I said, we have 4 variables and 2 domains, a national domain and a regional domain. And after that, we can easily run the allocation function. You can see that apart from the errors, all the input has been computed using the function that I showed you in the step 1. So here there is the iteration and the convergence of the algorithm. So the sample size, the final sample size, it's about 142 PSUs and 8,320 SSUs. Step 3, we can select now our sampling units. The first are the primary, so I can select the PSUs using the select_PSU function. Very easy function, just the location, which kind of location I'm going to use, and if I want select using proportional to size if true, or simple random sampling if false. Last step, we are going to select the secondary sampling unit. So also here we need the population data frame, the sampling frame, and the PSU sampling, so the output of the previous function. And we can see printed on the screen the different selection step for the different PSUs. Okay. Concluding, we tried also to compare our packages with two other very important packages that deal with allocation in multi-stage or complex service, the Prac Tools R package and the sample sites for service R package. unfortunately, these packages don't deal with multivariate optimal location. So what we did, we just ran R2bit for 4 times, and so here we can see the results in terms of selected PSUs and selected SSUs for the PracTools packages, our packages, and the sample size for Sarbase packages. And what you can see that is very clear that R2bit outperform both the packages in terms of both PSUs and SSUs, just some similar results in terms of SSUs for the inactive person, but for all the other variable and all the 2 steps, 2-stage R2bit produce sample size with smaller sites. That means that allow us to save basically a lot of money. The same information of the table are here on the graph, but you can see the gain, the save that are to be produced with respect to the 2 other packages. Okay, this is our email. Thank you very much for your attention. If you have questions, doubts, please contact us, and also please visit the GitHub website where you can find vignette and other very useful information about the packages, among with the developer version of the package. Thank you.
Okay, thank you, Andrea. Please, we have questions. Does R2bit incorporate user-specified expected response rates? I think.
Not directly. No, not at the moment. Is not a parameter that you can consider in the packages, but of course you can consider the expected response rate with trying to cope with inside the allocation. I mean, so you can try to play with the CV and with the input starting from this knowledge that the response could change, could be different.
Yeah, and another question, and the last one. Is it possible in R2bit to give the sample size and some variables frontier and the program to find the optimal solution?
Oh, sorry, could you repeat the question?
Yes, it is possible in this package in R2bit to give the sample size and some CV frontiers and the program to find the optimal solution.
So you mean the contrary, starting from the sample size and having back the. If I understand the question, yes, there is the possibility to have the reverse path. So starting from the sample size, I'm going to derive the expected error. So I want this sample size and what the error that I will have starting from this sample size.
Good. So thank you. We have no more questions, and if there are any, we can use our Slido number of session, which you'll find in the program, in the right part of the name of the session in the PDF program of the conference. So thank you for very much, Andrea, and we'll move on to the next speaker. a hybrid estimation of distribution, algorithm for joint stratification, and sample allocation. So we'll have here three contributors, Mervin Lung, Stephen Preswich, and Aragan Tarim from University College Cork from Ireland. So I think the presenter will be Marvin. Yes. Okay. You can unmute your mic, and the floor is yours. Thank you.
Can you hear me?
Yes, very well.
Okay, thank you. Okay, good evening, everyone. And as my Italian colleague said, good morning and good night as well, and good afternoon. So I'm very happy to be here talking to you today about a hybrid estimation of distribution algorithm for joint stratification and sample allocation. So basically, with joint stratification and sample allocation, you are defining your strata and your sample allocation at the same time, and that's where the joint word comes in. What we're trying to do is, as normal with stratification, we want to partition our population into mutually exclusive and collectively exhaustive strata. However, for our purposes, what we do first is we create basic strata from the cross product of auxiliary variables, and these can be continuous or discrete. However, as you kind of go down and you start to classify with, let's say, 3 or more auxiliary variables, the actual basic strata can be quite small in size. And there comes a point when, in terms of strata, especially when you have to consider non-response, they're not really functional. So it could make sense to combine them into larger strata, which is what this is about here. So, however, because you're combining subunits or basic strata together into larger groups, there's no fixed stratification starting off, and so you could have several stratifications, and as the problem grows bigger in size, this could run into this. There could be so many that your computer can't manage it. But getting back to what we're talking about here now, our stratification is, each stratification is a solution. The quality of each solution is basically what's measured by the sample size that you can allocate to it and still meet your precision constraints. And what we use to calculate that is the Bettel-Cromie algorithm. And as I mentioned, that as the problem grows inside, the number of possible solutions grows exponentially. And it comes to a point when we just can't solve it within normal time. So our objective function is basically to calculate a sample size that allows minimal allocation to each stratum and still meet your precision requirements, which are usually specified by the statistician at the start, and they tend to be either 1%, 5%, or 10%. And again, as I mentioned, we use the Bettel-Cromie algorithm, and we may calculate the sample size for one or more variables, which is quite useful. So you can set precision targets for more than one variable, and it will throw up a good sample size for that. Currently, there are a number of approaches which may be used to solve this problem. The first being k-means, which nowadays mainly can be used for an initial solution for creating one that can be further refined using the algorithms, the last 3 algorithms especially. But it can also find the optimal solution for smaller problems as well. The first algorithm that was written for this particular problem, or that could have been used for this particular problem, was written by Benedetti et al. In 2008, and it was basically a top-down clustering algorithm. And then that was followed by, well, there was a genetic algorithm before that, but it grew into a grouping genetic algorithm, and that's currently in the sampling strata package, and that's maintained by Balin and Baccaroli. And then there's two further algorithms, which are simulated annealing and hill climbing, and they're stuff that I would have presented in previous publications, and I'm going to introduce another one today. So as I mentioned, like when you have so many solutions out there, by definition, you're stratifying the data, and there is an optimal solution, but you just don't know what it is. And when you have so many possible solutions, you're looking into a black box, and you could possibly evaluate each solution one by one, and this is called grid search. But going back to what we said earlier on, you just can't do this when there's too many for the computer to process it. So that's why we try and optimize the search, and we call this black box optimization. One definition is a black box optimization procedure explores the search space by generating and evaluating solutions and uses this information to generate new promising solutions. And I'll explain that a bit more in the coming slides. So your goal is to locate the optimum solution with as little computation as possible. And that's what we want to do with this algorithm, as we want to do with the other algorithms, of course, too. These procedures theoretically can find the optimum solution, but more often than not, they tend to kind of converge on a solution that can be somewhat close to the optimum, and the proximity can vary. However, it's faster than the grid search, and it's preferable because, you know, as I say, you're getting solutions that are pretty close to the optimal. And what I want to kind of talk about here now is exploration and exploitation. And I think this is important because the algorithms I would have listed in the earlier slides, some of them are what you might call exploratory algorithms, and some of them exploit the solutions. And the exploration kind of is the likes of what the genetic grouping genetic algorithm does. It takes existing solutions and it recombines them. However, the recombined solution may vary to some degree and sometimes substantially from the original. Whereas with exploitation, you're making small changes to an existing solution, often producing better solutions, but you're keeping the essential structure of that solution intact. So first, before we go on to our hybrid, I want to talk about the basic underlying algorithm, which is the estimation of distribution algorithm. And what these do is they select promising solutions, and from these they'll actually construct a probabilistic model of a number of different solutions to actually generate new solutions. And they can be refined. The probabilistic model can be refined by selecting the best solutions and kind of tweaking that. And you may also introduce other features such as mutation or other kind of changes that you can add to the algorithm to kind of adjust the solutions as you run through it. But essentially that after a number of solutions, that in principle, because it's a probabilistic model, it should eventually kind of give you the probability model that's going to enable you to find the optimum solution. And the hybrid then, first, before we get to the hybrid, I need to tell you that generally speaking, the EDAs have two main computational bottlenecks, one being the evaluation of each solution, and then secondly, the model building, and that can slow it up. Hybridization is a technique which can be used to speed up the performance of the EDA. And what a hybrid is basically combining the exploration methods, which I talked about, such as the grouping genetic algorithm, with an exploitation method, such as the simulated annealing algorithm. And the combination of those basically allows you to explore, but at the same time, every so often, take the best solutions, one or more best solutions, and refine them, and then throw that back then into the exploration model again. our aim, what are our aims? We want to get to near optimal solutions by generating fewer solutions and to do so in less computation time. And I'll go into this more detail in the tutorial. However, I just want to give you an example of what it can do. This is a comparison of the hybrid estimation of distribution algorithm with the GGA. That's the grouping genetic algorithm. And for the Swiss municipalities data set, which is a small data set, but it's just useful for kind of doing some exploratory analysis. And with the heat, I'm going to call it, you get a smaller sample size for generating less solutions and in a lower processing time, and both of those tests were done on the same computer. At the tutorial on Thursday, amongst other things, we're going to look at downloading and installing the HEDA. What we're going to do then is, I've talked about generating starting solutions with the k-means algorithm, but I'm also going to talk about generating other types of, or other starting solutions using different algorithms, such as partitioning around medoids and fuzzy clustering. And from these three algorithms, we'll select the best starting solution, and we'll then use that with on the grouping genetic algorithm and the HEDA, and we'll see how they perform. And we'll also kind of look then at optimizing the hyperparameters, as that is a feature of using these algorithms, that there are a number of different parameters that could be tweaked, and that's another black box that you don't necessarily know the best parameters when you're starting off. You need to find the right ones. So I'm available to answer any questions if anyone wishes to ask them.
Thank you very much. Very interesting presentation and solution. So at this moment, there are no questions on Slido. So I think you can have the all contacts from the author of this research work, and you can address the questions also in the coming days or during the next presentation of you. So thank you very much for be present here. Thank you for the contribution, for your contribution and your team. So we'll move on to next presenter. So we'll have a presentation with the title Small Area Estimation for Sampling a Rare Population. So the author is Hisham Galal from Panama. So if you are online, yes, you are. So unmute yourself, and the floor is yours, please.
Thanks, Cyprian. Hi, everyone. Good day, good evening, and good afternoon, depending on where you are. I'm Hisham Galal, Associate Statistics and Data Analysis Officer with the UN Refugee Agency, UNHCR. And I'm here to talk today about a brief presentation on some work we've been doing on using small area estimation methods for constructing sampling frames of rare populations. So a bit of a background for those of you who are not familiar with the UN Refugee Agency. UNHCR was established in 1951 to provide care and protection for persons who have been forced to flee their homes due to conflict and persecution. We provide life-saving assistance, care and protection, and we help displaced populations to rebuild their lives. In the Americas, where I work, I'm here with the Regional Bureau. One of the largest situations, as we like to call them, that we're working on is the Venezuela situation, which, as many of you may be aware, the evolving socioeconomic, political, and security context in Venezuela over the past few years has resulted in driving mass numbers of Venezuelans from their homes in pursuit of safety and security and better lives elsewhere in the region. Globally, we estimate that there are 7.1 million Venezuelans outside their home country, and within the Latin American region alone, we have close to 5.9 million at this point, so close to 6 million almost. And while 6 million may seem like a lot, in reality, because they're dispersed over so many countries, 17 different countries, as a matter of fact, the numbers within each individual country is so low, and that becomes a problem for us when we're trying to do the representative data collection on those populations, because they become a rare population and it's not as easy to identify them, and there is no pre-existing sampling frame that you could select from, etc. In many contexts, usually UNHCR, whenever people hear about refugees, they think of refugee camps, which is a more manageable situation because you have people enclosed in a small geographic area. So you could just go and apply traditional two-stage sampling methodologies or mass listings or even use registration databases. But here in the Americas, because a lot of Venezuelans are in an irregular migration situation, meaning they do not have documents, they are not registered in any governmental database, or even if they do, oftentimes the data is outdated because of high population movements and mobility. We do not have anything that even remotely resembles a list frame or an area frame. And that is a major issue because on one hand, there is the whole leave no one behind principle of the SDGs, which you may be familiar with, which essentially means that if we want to ensure that services of the national governments are delivered to those who have been forcibly displaced, we need to make sure that they are visible in the national statistics and that there is statistically comparable data available on them to be able to monitor their progress and how far behind they have fallen in the achievement of the SDGs. But that is not the only reason as well. There is another probably even bigger imperative for us, which is to show what these displaced populations are able to contribute to the economies of the hosting countries, because we do not want people to see forced displacement as being an added burden, which states are where states are hosting foreign populations in need of international protection. But we also need to look at the positive aspects by being able to highlight what those people bring with them in addition to their needs. And focusing particularly in our presentation on the situation of Venezuelans in Chile, you may have seen from the previous slide that Chile is actually the fourth largest hosting country with approximately 450,000 Venezuelans. That is the official figure, last updated back in December 2020. And if you were to think about the options for creating a sampling frame for surveying the Venezuelans in Chile, normally the first thing that we go looking at is the census data. Except that in Chile, as you could see, the last census was actually carried out back in May 2017, and that is almost 1 year before the mass outflow started in 2018. And back at that time, the census estimated that there were around 25.5 thousand persons born in Venezuela within the country. This is almost 1/5 of the official estimate that existed at the end of December 2020. So within 4 years' time, the census data was not only terribly outdated, it was very out of touch with reality, and hence unusable for surveying the Venezuelan population. On the right-hand side, you could see another data source that we have been looking into for using as a basis for two-stage sampling. This is a two-phase sampling design, which is the CASN. That is a large national multi-purpose household survey looking at socioeconomic characteristics of the resident population. It includes a variable on place of birth, which we could use as a proxy for the identification of Venezuelans. But while the survey is designed to be statistically representative at the sub-regional level, at the regional level, which is essentially the first administrative subdivision of Chile, you could see that all the estimates for the number of Venezuelans in the second administrative subdivision, or even the third administrative subdivision, are highly variable to the point that they are completely unreliable. And we do not even have a single region where we are able to produce estimates on the population's distribution or location within a reasonable coefficient of variation of 0.2 or less. So what we were exploring is essentially the use of small area estimation methodology, which, if you're not familiar with it, it's basically the idea of using synthetic estimators built on regression models that are fit to data at a higher level and used to impute or estimate the size of the target population or target variable in smaller areas. So what we did here was to take the population estimates at the administrative level 3, at the third administrative level, from the CASN survey, as unreliable as they may be, but they are unbiased. So we were able to take them, combine them with area-based covariates on the same third level administrative areas from the 2017 census and fit them together to build a model using zero-inflated Poisson regression from BRMS using Bayesian methodology to build an estimator that we could use to essentially predict or estimate the number of Venezuelans at smaller, more granular areas below the sublevel administrative level 3, which is the finest level that you could find identifiers for in the national survey. But since the census includes more granular dissemination areas, we're able to run the model to estimate the prevalence of Venezuelans in those granular areas. And as you can see from the right side of the slide, because the Venezuelans are a relatively rare population, and hence the subject, the title of the presentation, most ADM3s within the survey sample have essentially an estimate of 0. But in reality, we have two kinds of zeros that we're dealing with. The abundance of zeros can be divided into actual zeros, meaning areas where there are no Venezuelans, but then you also have sampling zeros, which are areas where we estimate that where the survey estimates that there are 0 Venezuelans, but that is because they are such a rare population, and sampling is obviously it's only a part of the population that is captured in a sample, and it's a random process, so sometimes you end up with no Venezuelans in the area, even though in the sample, sorry, even though they do exist in the area. And as you can see from the chart, 72% of the administrative level 3 is disaggregated between urban and rural areas, were estimated to have 0 Venezuelans in them, which necessitates the use of a zero-inflated model. So what does our model look like? The target variable essentially draws from the census cartography, as you could see here on the left-hand side. The country is divided into 16 ADM1s, 56 ADM2s, 346 ADM3s. This is the finest level that you could find in the surveyed geographic location identifiers. And it's also disaggregated into urban-rural, so every ADM3 is split into urban-rural, and that is the highest level of disaggregation that we are, location data that we're able to retrieve from the survey. We fit the model to that level, and then we use it to predict not only what would essentially be the 4th administrative level district locality, but even the more granular level, which is the zones. The zones comprise essentially what is the most granular dissemination area for the census data set. There's 15,500 of them, and you can see the distribution of the size of them at the bottom left corner of the screen. And there is a median of 86 households per zone, or dwelling, sorry. And while zones do not constitute enumeration areas for survey purposes, they are essentially the most granular data that we are, the most granular geographical grouping or level that we're able to retrieve from the census data set for our estimations. And even though 86 is relatively high number, but you could still think about if we were to run a listing operation checking every single household for in a 2-stage sampling design, 86 households remains very much manageable in the median. Perhaps once you get to the 3rd quartile, obviously the max, it's not that manageable, but within 86 it is. And the reason you could see that we have this ridiculously high number in the 3rd quartile and maximum is because of vertical growth in cities. So colleagues who are working with surveys in highly dense urban areas are familiar and aware with the issue that because of all the high-rise buildings that are constructed these days, it's fairly common to find a single city block with over 1,000 buildings or so. And that's not something that we could have simply avoided given the public data that is available within the census. In terms of covariates, without going through them one by one, we have 3 different levels of observation. Those are 17 indicators that are drawn from the census microdata, and which are essentially what the government reports in their own publications on the census data. We combined all these 17 indicators using a projection predicting algorithm for variable selection and trained them on the number of Venezuelans per urban rural subdivision of an ADM3. to produce a model, and zero inflated model, as I had mentioned earlier. And this is not the entire full set of variables, but these are 4 variables that I wanted to extract to highlight in the presentation. You could see, for example, on the right-hand side that the number of, or the share of international migrants in the 2017 census has a strong influence over the density of the number of Venezuelans per persons within an ADM3 or within any given geographic area. And likewise, similarly, there is a strong positive correlation with the availability of acceptable housing, so that we know that Venezuelans are not moving into neighborhoods with poor overall housing conditions, as well as with employment. And interestingly, the one indicator where we have a negative correlation is with average years of education, which suggests that as the overall level of education in a country in ADM3 increases, the propensity or the likelihood of finding the number of Venezuelans who end up in that locality or location tends to go down, which is a bit unexpected. In terms of model fit, what we have is that the model is able to estimate over a 10-fold cross-validation. We have an R-square of 0.72, which is relatively good, I would say, except that there is a bit of heteroscedasticity. As you can see, that the errors are not exactly in line with the absolute line, the diagonal, sorry. And there is a clear pattern that they're not following, the residuals are associated or correlated in a way with the actual number of persons. In terms of coefficient of variations, you remember from the earlier box plot that while none of the COVs had fallen below 0.2, here after the model is fit and we use the estimates from there, almost 80% of all the estimates at the ADM3 level disaggregated by urban-rural are now below the 0.2 publication threshold, which suggests that the model provides very good estimates. And finally, then we take the data from the ADM3 level and we apply it at not the ADM4, even the smaller one, the zones. As you can see, this is an area in Santiago where we have applied the model. And as you can see from the estimates, we're able not only to get estimates of that number of persons per zone, but because it's a Bayesian model, we're also able to get estimates of the coefficients of variation or the reliability of those population estimates per zone, where each zone is a relatively compact, small area with a manageable population that can undergo a population listing, which essentially serves for us as a basis for a sampling frame to be able to conduct representative surveys of this population. In terms of perils and promises of the approach, I think one thing that we have been excited about is the minimal data requirements, because essentially you just need a nationally representative survey that includes an identifier of the rare population that you're working with and census data, both of which are often available in most countries and publicly microdata available. No need to go through an NSO. Because the model is not using any covariates from the survey directly, there is less sensitivity to the issue of census data being out of date with the covariates from the survey, which is something that is often an issue that plagues traditional small area estimation methods. And another plus we have is that we are able to estimate uncertainty in the estimates, which could in one way or another inform how much we want to actually allocate to the smaller areas based on the uncertainty and their estimates, so we don't end up doing a lot of listing exercises in areas where there are highly uncertain numbers of persons. In terms of challenges, I think while the approach is generally applicable, there is a bigger question of how do we identify forcibly displaced persons within survey data. We're lucky in this region that the Venezuelans in general are considered to be a forcibly displaced population or refugee-like population under the regional Cartagena declaration, which makes it simple to identify them. But then when you look at refugees in other contexts, oftentimes you need an identifier that tells you if a person is a refugee or not, because there aren't so many countries or nationalities that enjoy similar group status across the board, which may limit the replicability of this approach to other regions or contexts. And then there is obviously the issue of data availability, because in many contexts where we have forced displacement, the national governments are also lacking in capacity. Think in particular of certain parts of Africa, Asia, etc., where we have large numbers of displaced populations, but then we do not have as solid national statistical systems as we may have here in Chile or other parts of the Americas. And as such, you wouldn't be able to implement something similar. And then there's the issue of the granularity of dissemination areas that I had alluded to earlier, where because the most granular areas, the zones in certain parts of the country may constitute a large number of dwellings, it would still require an arduous listing exercise, which may go beyond the resources available for traditional surveys. And getting more granular data at the city block level beyond the zones may require going through confidentiality agreements with the NSOs, which complicates things a bit. And then finally, there is obviously the question of validation of the methodology and of the estimates. And because we know that models tend to give very minimal errors, and this is a synthetic estimator, it's not even eBlob, empirical best linear unbiased predictor. We know that the errors we're getting are on the conservative end, and there's always the question of how can we validate those estimates and what do the errors mean in the field in practice for data collection. Thank you very much. Apologies if I've taken a bit more than I was scheduled. Yeah. I actually thought I was going to be quick, but it's
yeah, thank you very much, Hisham. It's of course a very interesting presentation, and with practical results, with the special situation with the rare population. So, okay, thank you for your presentation. We have no questions from the audience in Slido, so we can now move on to the next presentation quickly. Using R in Kansas to edit and input labor income on National Household Sample Survey in Brazil. So we'll have two contributors here, Fernanda Karin Ruiz Baptista from Instituto Brasileiro de Geográfica e Estatística from Brazil, and Gabriel Henrique Oliveira, also from the same institute. So please, we'll present, I think it's on, so the floor is yours, please. I think you have to unmute yourself.
Can you hear me?
Yes, now we
Yes.
hear you.
Okay, I'll share my screen.
Good.
Now the screen is on.
Perfect.
Okay. Okay.
Maybe if
Good
you can you make the full screen?
Full screen, okay.
If it's possible, Control L if it's PDF. Okay, perfect.
Okay, good morning, good afternoon, or good evening. I'm Fernanda. Here with me is Gabriel Assunção, who is also author of this article. We are from Brazil. We are statisticians, and we work for the Brazilian National Statistical Office, IBGE. I will present about using R and Kansas to edit and input labor income on National Household Sample Survey in Brazil. So, Continuous PNAD is the National Household Sample Survey. It is produced by IBGE and has its main objective to capture information about the labor force and its percentage changes in rates in the short, medium, and long terms, as well as on other topics such as education, housing, other types of work, among others. The indicators related to the labor force are disclosed monthly to Brazil through mobile quarters, quarterly disaggregated for Brazil, major regions, federation units, metropolitan regions that include the capital and the capitals. The other research topics in general are published annually. More about continuous PNAD. In sample surveys, we must deal and track sampling and non-sampling errors, such as item non-response and measurement errors. A sample designed to collect data from 210,000 households per quarter is not different. Thus, we track missing data and inconsistent values with data editing and imputation techniques. So this presentation aims to show a part of this process. These are some links on the IBGE website with technical information. The first link is in English and the second is in Portuguese. The methodological concepts about editing and imputation is on the third link, is in Portuguese. So how we do to edit and input data? Here I brought a summary of the process of edit and input. The monthly process of the microdata happens on a system developed by IBGE using the software's SAS Enterprise Guide with pre-established deterministic rules. CS Pro, we use a form with auxiliary variables for visual identification of outliers of quantitative variables, and cases. We use for probabilistic imputation using the nearest neighbor imputation methodology, the NIM. So more about the NIM, we can see on Statistics Canada website. NIM is a hot deck method that is, it's assign the missing value from a record with an observed item we call the donor. The record with a missing value on that item is called the recipient. And the incorporation of the complex sample survey design happens on R. Here I bring an example of this process. We used the labor income because is one of the variables with the highest non-response rates in the continuous PNAD. One of the reasons is the fact that part of the answer is proxy, and another point is the fact that respondents do not feel comfortable in answering, especially among those with better socioeconomic and education levels. For this reason, we chose to carry out an exercise of edit and impute labor income as similar as IBGE does with the public microdata of the fourth quarter of 2019. We divide this process into 8 steps, and now I'll show some part of them. First, we load the package PNAD-C IBGE. Gabriel Assunção is the maintainer of this package. If anyone have a doubt about the package, he's here to answer. So in step 1, we downloaded the data for the fourth quarter of 2019 with the variables we will need. In step 2, we created the auxiliary variables that we are going to use in Kansas, and the dummy, which is the indicator of those who have labor income. Then we sorted the data by UPA, which means primary sampling unit, and V1008 is the household ID, the secondary sampling unit. Then, in step 3, we did the filter for the individuals which have labor income in cash or products and goods. In step 4, we retained in the order the same explanatory variables used by IBG to create the Kansei input files. In step 5, we put missing on 10% of the records of labor for individuals who had more years of schooling, with the assumption that the non-response in labor income is correlated to a higher level of education. In step 6, we create the unit.txt, is the Kansei data set. The change here from NA to -1 is a trick because Kansei understands -1 as a valid answer. In step 7, the imputation was performed in Kansei with the same configuration used in the continuous PNAD, that is, the same explanatory variables, weight associated with the variables, and the distance function with the same parameters. Then we got the data with imputed values. I will not go into the details of the Kansei procedures because we will not have time. In step 8, we read dataset with imputed values and changed records from -1 to NA, aggregated with the other variables, and created the new derived variables to estimate the labor income. Here are some functions to estimate. For estimate, we load the survey package and the table package because they will apply the sample design. We did the estimates with the public microdata and the data set with imputed values to compare these results. The functions we used to estimate were SVY mean, SVY quantile, and SVY hist. Here is an example of the functions. And here I bring some statistics of all income labor. The unit of measure is in Brazilian currency, reais. So here we have VD for 4,019 is the usual labor income, and the 4,020 the effective labor income. Here we can see that the estimates are similar. The values are quite similar, and for both of them, here 2,322 and 2,252. And the histogram of the logarithm of all income labor, we can see similarity on the distribution. Therefore, we conclude that the imputation brought results very close to the public microdata. Here are some references, those one I have mentioned before. And if anyone is interested in our scripts and Kansei's input files, get in contact by email so we can share the R and Kansei's stuff. So thanks, that's all.
Thank you very much, Fernanda, for this presentation with, I'm sure, the good results of applying this package, these functions. So congratulations to all the presenters from and contributors to our community from this session. So we are only 4 minutes late in this session. Thank you very much. So I think I will come back to the Mark to have the floor for the next session, which is a keynote session. So Mark, thank you for understanding. We are a little bit late. You have the floor now. Thank you.
Thank you for a wonderful session. I'm just going to, while I introduce our keynote speaker, I will just share my screen so you can see the Slido number. So Julia Silgi, I think she's very well known in the R community, but I just want to summarize some of her achievements. She has a PhD in astronomy, like many sort of early data scientists like me. She also started in another field, and she had several academic positions after that. But in 2015, she moved into data science, where she very quickly became proficient in R. And one of the things that I think she became quite well known with is the tidy text package that she published on CRAN, followed by a book on text mining and analysis using tidy data. Since 2020, she works at RStudio, which is now called Posit. I still have to get used a little bit to the new name. She works at Posit as a software engineer and a team leader in the area of machine learning and ML ops. Recently, she wrote a book about tidy modeling with R together with Max Kuhn, who is also working at Posit, I believe, in the recipes package. And before that, he worked on the Caret. So also a well-known R programmer. Julia is also an avid blogger and communicator. She's done several keynotes, international keynotes, also on the Big Use R conference. So we are really happy that she is joining us today. And actually, I use one of her blogs every time when I'm teaching sentiment analysis, because she has a very nice and very famous blog on sentiment analysis on Jane Austen books. One thing that I didn't know, but what I found out when I was researching a little bit for this keynote, is that she's also in the technical advisory committee of our colleagues of the US Bureau of the Labor Force Survey. So there's, in that sense, we are a little bit colleagues as well in official statistics. And today she's going to talk to us about data visualization for machine learning practitioners. So Julia, the floor is yours.
Thank you so much, Mark, for that extremely kind introduction. I am going to make sure I can see the chat here, just so I can, oops. So I can see if anybody comes in here. Thank you so much for that extremely kind introduction. And I am really happy to be here. Okay, I'm all good to go. I thank you so much for this introduction. I will say that my experience with the Bureau of Labor Statistics in the U.S. Has given me such an interesting, I've learned so much about how statistics is practiced in these official government departments, some of the tensions, some of the things that people want to do, are moving towards doing more. And it's been such an interesting learning experience. When they, I will also admit, when they first reached out with like a nomination, I asked, are you sure I'm the right person? Because, like Mark said, I came from, astronomy and astrophysics. I transitioned into data science. I did not have a formal statistics background, and I do not, certainly don't have an economics background, or any previous background in labor. It turns out what they really wanted someone to come in and be an advisory committee member for was about machine learning, about using these modern machine learning methods with the kind of data that they have. And so it's very relevant to what I'm talking about today. What is the practice of machine learning like? How can we use it responsibly? And today, the specific focus that I'm going to be using is how do we use data visualization during the process of machine learning? It's important in many different ways, right? Data visualization is one of the key communication tools that we have when we are speaking outward, when we are when we're talking about our results. But what we're talking about today, what I want to focus on today, is actually how machine learning is used as a tool to make better modeling choices. So it's a tool of the system designers and operators themselves. So that's you all, right? Like the people who may be using machine learning methods to make some tool, in this case for official statistics. How do we make more reliable, better, and more fair machine learning systems? So, as I'm sure you all know, data visualization is this hugely important tool. All kinds of data practitioners use it all the time, not only when we're doing machine learning. So, a lot of what I'm going to say today, what we're going to reflect on today, is true just because data visualization is so effective at surfacing information to us as human beings. So when it comes to data, these visual ways of perceiving information form how we think about the work that we're doing, how we understand the problems that we're solving and the models that we're building, and also how we decide. So I especially want to focus on data visualization as a support or aid for decision making, because building models or machine learning systems is a quite a complicated, involved task that has many different ways to make mistakes, and I want us to explicitly frame like the plots and the graphs that we make the way Tamara Munzer does here. We use our, computer code-based systems, maybe R, probably if you're here at this conference, to represent data sets for a specific purpose when we're building models. And the purpose is so that we as machine learning practitioners are more effective. So when it comes to models and machine learning, more effective can have a couple of different meanings. So that could mean more accurate, it could be more practically appropriate, it could be more fair. And so we're going to talk about a couple of these here. So I, as Mark mentioned in his introduction, I have been working on open source software in R for modeling, machine learning, and ML ops, which I'll mention a little bit what that is. One of the big projects I spent a lot of time on is called Tidy Models, and a lot of the examples I'll be showing today use Tidy Models code. So if you haven't heard about Tidy Models, the goals of it are to provide a consistent and flexible framework for modeling practitioners. So from those who are just starting out, like it's appropriate for beginners in machine learning, and to those who are very experienced. It is customizable, extensible, and so useful to those who are very experienced in machine learning as well. Another goal of it is to harmonize the heterogeneous interfaces that exist in modeling in R, and to encourage good statistical practice, both by the design of the software itself and the documentation and how we speak about it. So I'm glad to get to show you a little bit of what I've worked on today, but a lot of what I'm going to talk about and cover isn't specific to Tidy Models. It isn't really that specific to R. What we're focusing on are these data visualization practices for real world folks who are engaged in building models. So let's start by asking this question. When do practitioners build data visualization? So asking this kind of question requires us to think about the process of model building and to build a mental model of modeling, if you will. So I'm gonna put this out there as like a schematic that I'd like to think about when it comes to what might happen during a typical process of let's say a modeling practitioner getting from the point of seeing some data, maybe for the first time, to having a working model. So the model process starts with exploratory data analysis. This is a systematic, iterative process of exploring data to investigate it and to generate questions. It's kind of a question generation kind of part of this process. Next comes feature engineering. So this is the task of transforming our original variables that we may have had in our data to some variables that are more useful to be a feature in our model. Like a really straightforward example of this would be maybe to create dummy variables or one-hot variables if the model that we need to train only can deal with numeric input. So after this comes model fitting and tuning. And I have represented this here with lots of skinny lines to represent resampling. When we use using resampling is part of this good statistical practice when it comes to modeling and machine learning. We don't want to estimate how our model is performing with the training data. We don't want to do it with the testing data because we have to save it to the end. So we can use resampling data to make these simulated training sets. Typically, when you are starting out in a modeling process, you don't really have a priori a lot of like solid information about what kind of model is the right kind of model to use. So you may try quite a number of them. You know, machine learning is an empirical field. You know, there are guidelines, there's people's experience, but really often the only way to know what's the best model to use for a certain data problem is to try it and then to see which one turns out to work the best. And then we say, aha, I'm going to evaluate these models. I'm going to measure how well a model performs using some metric that is appropriate to that specific kind of model and that specific kind of problem. Notice, however, that we're not done. We're not done. In real world modeling processes, very seldom do you go through one round of that and then you're finished. Typically, this process is iterative. You see your results. Maybe you look at the kinds of observations that had incorrect predictions, and that causes you to go back to exploratory data analysis, looking at the data more. You spend more time doing feature engineering because the results that you get when you did model evaluation showed you need to change how you're doing feature engineering or custom build different features than you had before. So this is an iterative process that we come back to these different stages. It's not like a one shot and done. Also notice that we're headed towards some goal or some output. You're building a model for some reason. So that might be communication, right? You might be like asking maybe inferential questions or why questions. So you might be just headed towards communicating the results of your model, or you might be headed towards deploying your model. So taking the model that you have and integrating it into the infrastructure of your organization's infrastructure so that the model can make new predictions on data in a predictive sense. So this past summer, I transitioned from working full-time on tidy models, so like model development, to working on tools for model deployment and model maintenance, maintaining models. This is what we call MLOps. So I'll just briefly say, if you're interested in learning about MLOps with R, I encourage you to check out Vetiver. So Vetiver is our project for versioning, deploying, and monitoring models. So this diagram gives you maybe kind of a little bit different like mental model of what the model lifecycle looks like. This is maybe what we think about once we started thinking about deploying and maintaining your model. This talk today, though, is more about this model development, the model development part of the process. So I've put this as a skinny bar here, but really it's transitioning into a whole other set of tasks, depending on the purpose of the model that you have. So we're going to keep our scope on the model building. And you know, machine learning practitioners can, of course, make plots at any point during this process, but I want to make the argument that there are two phases of the modeling process where practitioners use data visualization the most. The first of these is EDA, exploratory data analysis. Like I said before, this is this iterative phase of investigation, question generation, and refinement and exploring. So maybe this is a phase that you might think, wait a minute, that's not really part of machine learning. That comes before modeling and machine learning itself. But we're going to see how the investigations and understanding that you gain during EDA have a huge impact on the models that you build. The second is model evaluation. This is the part of the modeling process where a practitioner has trained probably multiple models and then is assessing, measuring, comparing how well different models performed. So if you were able to like look over the shoulder of someone who is building a model, I think these two stages are when you would see someone creating the most plots. And in my opinion, using visualization in a lavish way at these phases is usually a sign of a healthy machine learning process. Why is that? And that is because these two phases of the machine learning process are the points of the most important human decisions. Validation of these decisions can be difficult. Often, you know, you might hear phrases like there's art, not science involved. And that's because it's full of trade-offs. And visualization during these two phases, visualization is used as an aid or support to carry out these tasks, these decisions that are full of trade-offs more effectively. So let's start with the first one, EDA, and let us ask the question, why are these plots built? So at a very high level, the plots during EDA are built to understand the data. So when a practitioner starts out on a modeling project, this is one of the first substantive tasks that are being faced. So the reason we as practitioners need to have this understanding of the data is because there is about to be a whole bunch of decisions to make as we build a model. And these data visualizations let practitioners ask and then refine specific questions related to modeling goals, like what kind of model is appropriate here. This feeds into that feature engineering phase that we talked about before. What kind of pre-processing is needed? And all these kinds of questions are ones that machine learning practitioners ask, refine, and answer by making plots. So let's finally look at some. Let's look at some plots and think about them. So some of the plots that people make during the EDA process look like very familiar statistical graphics, like this scatter plot. So this plot uses a data set called Palmer penguins. So it's penguins who are observed in Antarctica near Palmer Station. And this plot maps each observation to a point on the plot. And aesthetics of the plot, like the positions, X and Y, the size, the color, these all represent things that have been measured about these penguins. So exploratory graphics like this are really important for machine learning practitioners because they help us, well, for starters, they help us understand the type and amount of data we have. And then going further, they visually highlight relationships in the data that we can use in feature engineering or models. So here we see these relationships, right, between the shape of the bill, the different species. You know, if we wanted to build a classification model, maybe to predict the species of the penguin or the sex of the penguin, based on other kind of measurements that we have of their body size and their bill shape and whatnot, these relationships that we discover inform this kind of steps that we can make moving forward. Now, plots for EDA don't always look like super classical statistical graphics. So in some ways, this is just a scatter plot, but the mapping is different. It is, in fact, a map. So it's showing a data set of trees in San Francisco. So that empty area there is Golden Gate Park, and other empty areas are smaller parks. And what we're mapping here is who's in charge of maintaining each tree. Is it the Department of Public Works or is it somewhere else? So if our goal is to train a model to predict the maintainer, say, then a plot like this is really impactful. We can decide what kind of model we might want to try. So like, you know, we might look at this and think, oh, I'm not going to bother investing much time in a linear model. I'm going to go straight to a model that can learn interactions natively, like a tree-based model. We can observe from visualization what kind of predictors we expect to be important, and you know, there's things we can learn about the data set just from using as a visualization tools in our process. So given these things that are true, you know, machine learning practitioners use visualization during EDA to make so many different kinds of plots. It's important that the tools we use during this phase facilitate fluent iteration through lots of kinds of graphs. So I have personal experience with decades of various kinds of scientific plotting tools, and my opinion is that learning and absorbing the concept of the grammar of graphics is a huge step in efficient iteration when it comes to visualization. And adopting some system that applies the grammar takes you just a huge step forward in efficiency when it comes to this task of asking, refining, and answering questions to get ready to train models. So I believe, you know, we're all R users, at least part-time here, and ggplot2 is the best known system that implements the grammar of graphics. Almost all the plots I'm going to show you are made with ggplot2. If you are a Python user, there are visualizations that implement the grammar of graphics somewhat, and those include Altair, Plot9, and sort of Plotly. So if you find yourself needing to choose a visualization system, you know, maybe outside your normal tools, look for things that uses grammar of graphics because it helps you be so efficient. So investigations during EDA inform decisions about what kind of models to train, and also what kind of decisions should we make in feature engineering. So in tidy models, we capture data pre-processing and feature engineering in the concept of a pre-processing recipe that has steps. So you start with your variables pantry. You go and you see, like, what's in my pantry? Which variables do I have? And then we define steps. What are the steps I need to go through to get this data ready for modeling? And then we prepare the recipe using training data, and then we can apply them to any new data sets, like testing data or new data at prediction time. So this design choice protects against data leakage during pre-processing. This is a really defining feature of the design of tidy models. The specific feature engineering steps that people choose to use are often chosen because of what we learn during EDA. So let's look at another little example data set. This is a data set of houses in Ames, Iowa. And we have a lot of information about these houses, like how big they are, where they are located, and their last selling price. So this plot shows the sale price on the y-axis, say that's what we want to predict, and the latitude across the city on the x-axis. There's kind of a big hole there. That's where Iowa State University is. And then there's kind of some unique and complex structure and price as we move across the city. We have options for how we're going to model that complex structure. And one thing we could do is to use splines to build new features for modeling based on, say, latitude. But the thing is, we have to decide how many spline terms to use. So this is 2, and to me, that doesn't look like it captures the real structure very well. 5 looks better. I believe 10. 10 looks good. 20 seems okay, but I'm starting to feel just a little bit skeptical. At 50, I no longer believe this. And at 100, this is just silly. This is just silly. So what's great about data visualization during the process of EDA is that we as machine learning practitioners can see and absorb this and then use this to make decisions, use this to make these kinds of trade-offs, make these kinds of choices that need to be made as we build reliable models. So if you use tidy models, these decisions that I was just talking about may end up looking like this, with a feature engineering recipe that's defined with steps that transform and prepare our data to get it ready for modeling. So whether that's, dealing with factor levels, creating a dummy or indicator variables, or, setting those 10 spline terms. So whether it's for engineering new features, choosing an appropriate model, or understanding data quality, data visualization during EDA has a huge impact on what model practitioners do later on. In some ways, it's the foundation on which the rest of the model process is built. So it is often possible to estimate the best answer or value or option for some of these choices that we've talked about using empirical methods. So this is like tuning. If you have heard people about talking about like tuning a hyperparameter, like the number of spline terms, but it's nearly impossible to remove entirely the element of human judgment from these choices, or at least it's a bad idea. Machine learning algorithms are astounding. They are incredibly powerful and capable of learning patterns from large amounts of data. So vigorous adoption of EDA as part of the machine learning process is one of the safeguards that we can implement against ending up in a situation where you have to ask yourself, whether it was really a good idea to just deep fry your data. All right, so next let's talk about model evaluation, the phase where we have trained, possibly tuned models, so we have predictions to compare to true values, and we can assess how our models are performing. And let's ask the same question: why are these models built? So at a very high level, here what we're doing is we want to understand the models. So specifically, what we're doing is assessing model performance. So this is the point at which, we as model practitioners have to reckon with questions about success and failure, and ask, did this work? Did this model work? So the process of model evaluation also allows us to interrogate subgroups. This is typically where discussions of model fairness come in. A lot of the current work in machine learning bias and fairness focuses on how models perform differently for different groups. Maybe for different protected classes, like legally protected classes. Then these may not have been included directly in the model at all, but we can still see differences because maybe certain predictors are proxies for those protected legal classes. Model evaluation is also concerned with why a model is making the predictions it does. So for all of these questions, practitioners heavily use data visualization for a lot of the same reasons it's used during EDA, which are largely the same reasons that anyone ever uses visualization. The plots that are used to ask and answer these questions show relationships more clearly that often are difficult to see otherwise, and they are supports or aids for making decisions that need to be made. So, there's lots of in common. They have lots of in common with the other kinds of plots, but there are some pretty unique things to note about plots used for model evaluation. So let's explore some of those. So one of the sort of unique things is that these plots often involve graphical norms or idioms. So this plot shows how two model evaluation metrics for a regularized regression model, like a lasso regression model. There's RMSE and there's R squared. These plots show how do they change with the regularization penalty, like how strongly regularized it is, how much stuff am I throwing out as I am fitting. So someone who's familiar, say with like lasso regularization, look at this plot and they really quickly recognize like, did it work or not? Is this a model that needed a lot of regularization or a little bit? And you can look at, say, the R squared and see kind of quickly like how well, or in this case maybe how not well, the model fit the data, or the model explains the data. So this whole plot is like a shorthand or an idiom, and it packs a lot of information for a familiar audience, an audience who has looked at plots like this before. This plot is similar. This is a receiver operator characteristic curve. There's 10 of them here, actually. It's for a model trained on those Palmer penguin data that we discussed at the beginning. And this is a visualization that, that represents how well a binary classification model is doing. So the more up in that left-hand corner the curves are, the better the model is doing. The axes have the true positive rate and the false positive rate on them. And ideally, we want both of those to be great. We want it to do a really good job identifying both of those. So this is another example of a model evaluation visual idiom. It's familiar to modeling practitioners, and it can be used to compare models, to assess a model, and so forth. So these kinds of visual idioms are a great fit for automatic plotting methods. So when we talked about EDA, I highlighted the need for a really flexible plotting framework that can be used to create any kind of plot fluently. And let's adopt the grammar of graphics and learn the grammar, and you can just create anything you want in a really flexible way. So I'll be honest, a lot of model evaluation plots are the same every time. And practitioners can be better served using shortcuts, either that you build yourself or built by tool builders like the Tidy Models team, because it can be a hassle to copy and paste the same code for an ROC curve every single time. However, at the same time, not all plots for model evaluation are these kinds of really standard idioms that are considered very normal and typical in our community. So this is a model evaluation plot for a model that predicts the class of a volcano. And each hexagon shows the percent of volcanoes that have been classified correctly within that little area on Earth. So this is like a very bespoke and custom model evaluation plot. So you do want to know about some key automatic plotting methods because they're a useful part of like the visualization toolkit for a machine learning practitioner. Having that fluency, it's still very important. There's not always going to be an automatic method or one of these idioms that exists already to visualize model performance in the way that you need to in your specific case. I focused so far on model evaluation plots that show us as practitioners how models are performing in terms of performance metrics like, say, RMSE or accuracy or some other similar metric like that. So some current work on model fairness falls into that category, but looking at differences in performance for different groups. Model evaluation activities can also encompass model explanation. And visualization is, again, a key tool in explaining models. So model explanations fall into two main categories. The first are global explanations. So we evaluate what features are important in the model predictions overall. So this plot is from the San Francisco trees example, and the length of the bars here correspond to how important that feature is in predicting, using a random forest model, whether the tree is maintained by the Department of Public Works or not. And so this is how important globally overall for the whole model overall. So it turns out having a private caretaker is the most important, and then after that it's the spatial information, like where was the tree in San Francisco. So what this gives us is a global overall for the whole model, and this actually uses the tree structure in the random forest model, the 1,000 trees or however many it was, and uses the tree structure that we know about to get this this result. The other main kind of model explanation is feature importance at the individual observation level. This is sometimes called local feature importance. So one framework that I like using for this is DALX. There's support for tidy models and DAL Extra, but you can use it with lots of different kinds of models. So here we're going to create an explainer for a random forest model, going back to that data, that housing data in Ames, Iowa. And we're gonna look at what explains the price of a specific home. Let's look at this duplex. So this first thing we're gonna look at, we know its neighborhood, how big it is, where it was built. We know all the predictors for it. And so we can look at a measure of local feature importance, which just means not for the model overall, but for this specific duplex. There's multiple ways to compute local feature importance. This particular plot shows a Shapley additive explanations. Plots are values for the price of the duplex. And so a Shapley value is the average contribution of a feature value to the prediction in different coalitions, which kind of just means combinations. So the box plots show the distribution of the values over the multiple different coalitions that we tried, and the bars show the average contributions for this individual house. So we see here that the this duplex is its age makes it that it is pushed lower. Its price is lower because of its age. Its living area has pushed its price lower. That it's a duplex has pushed its price lower. So this home, this duplex home, we know what for this individual case, what is pushing it up, or in this case, almost entirely down. Why it has a lower price. We also can build up to global explanations from individual observation level explanations. So this plot shows a partial dependence profile, or a bunch of partial dependence profiles for these same homes. So the gray ones are for individual homes. So it displays how the expected value of the model prediction, the price, how it changes as a function of this feature. So here, that's the size of the house, how big the house is, the living area in square feet. So what happens here, in real life, each one of those houses has one size, but the idea of these partial dependence profiles is that you go to the model and you say, here, I have this house. What is its predicted price? Okay, what if it were bigger? What's its predicted price? Like you change the you basically are asking the model, and it tells you then how it behaves with lots of different examples. So all the little gray lines are individual houses, partial dependence profiles for the little different houses. And what this allows us to is we can aggregate up. So we can use the individual level feature importance and then aggregate up, even for example, to see and highlight the model's behavior for subgroups. So we can see for all of these, you know, as we get to bigger houses, they're more expensive, but it's kind of flat on the upper and lower ends. And then we can see that, for example, the one family houses are more expensive than the townhouses, and the duplexes, you know, are kind of near the bottom. But it's complex, the behavior. Like we don't have, it's not linear, which is because we use a random forest model, which is not linear. So, and we can see and understand this through these kinds of visualizations. So for both global and observation level model explanations, these plots are used by the creators of these machine learning systems to evaluate them and to understand them. So at this stage of the modeling process, we are again at a point of important human decision. And model explanation together with model performance can be used to make choices. So that through this whole exploration of data visualization and the machine learning process, we focus on plots made by the system designers and operators for themselves as a tool to make better modeling choices. These are plots that are made by practitioners for practitioners. So often when we talk about data visualization, we only think about it as a communication tool. And of course, you know, it 100% is one of the most important tools we have for communicating about data or models or anything. But we also can think about data visualization's other functions, like its ability to be used by system designers to understand that system more fully. So parts of the machine learning community recently have talked about what are called participatory approaches to machine learning. This is where system designers like purposefully partner with those impacted by a system. So like we might call this the user in some cases, or in the official statistics case, you know, this might be people who have, you know, enrolled in different surveys and whatnot. So we can partner with those in shaping or designing the machine learning system. So I think this is going to be interesting to watch, because that kind of practice or approach is going to have to impact choices made through the model process, including what kind of plots we make, because it might actually change the answer to this question somewhat. Who are these plots for? Are they for us as practitioners? Is it for a broader use? What I don't think will change, though, is the main purpose of any given data visualization. Some plots are created to help us understand the data that we start with, the input for the models that we create. So investing in data visualization to understand data in the machine learning process, that's like laying a strong foundation. Some plots are created to help us understand the models that we create, the output. So here, careful visualization practices in model evaluation, this sets us up for success, making models that are as accurate, as appropriate, and as reliable as possible. So with this, I'll say thank you so much for having me here. I want to be sure to thank my Posit, formerly RStudio teammates on the Tidy Model Team. I too am still getting used to the new name. I also want to thank the folks who organized the Tidy Tuesday project. Tidy Tuesday is a weekly social data project that most of the data sets that I shared today here are from. So thank you so much, and we can see if there are any questions that folks have.
Thank you very much, Julia, for a really fun and interesting presentation. We have a few questions in Slido, and I would like to encourage people, if you still have questions, this is your chance to ask them directly. Let me see, I will just start in the top. Yeah, so one question is on the communication of uncertainty in the output. So this is something that we are not very apt, I would say, in doing in official statistics. Kind of, we like to give one figure, but of course, like any figures, ours also have some uncertainty in them, and there's some debate like how can we communicate this? And visualization would be perhaps one good way. So do you have any ideas on this? That's the question.
This is, first of all, a really active area of research that people are trying to understand. How do people understand uncertainty when you show them visualizations? One thing I have found useful personally when talking to stakeholders is to use summary statistics very sparingly, and to try to show samples of size appropriate samples of how things are distributed. So the tools that we have now for making visualizations make this very, very doable, right? Like we're not limited for just showing summary statistics. So for example, if we can show what are the predictions for many people, let's say it's people in a data set, we're generating some predictions, we can show whole distributions, we can show distributions disaggregated by some important characteristic that's important to these stakeholders. So I think that I think this is a really interesting research to keep up on. One thing I personally have found helpful is to be sparing in my use of summary statistics and try to show appropriate sampling of distribution so that people can see the underlying distributions. And I find that even not deeply technical stakeholders can often grasp those kinds of plots. So, if you want to think about that one that I showed you with all the little gray lines for how the price of housing changed as the size of the house changed, like that's a kind of plot that I feel like I can show to any kind of stakeholder, not a deeply technical one, and explain it, and they're like, oh, okay, like I see, and I think I can understand how this model is working.
Yeah, reminds a little bit on how they visualize uncertainty in weather reports. And this is
yeah, you're right.
Let's see, there's more questions. There's no question, but thank you for the presentation. There's one question on, could you comment on what are the pros and cons if you compare tidy models with scikit-learn?
Yes, so there is a great lightning talk about the quirks of scikit-learn by Chelsea Pelletieri. Let me see. Okay, I'm going to find it, and please don't start playing. Yes. Okay. I'm going to drop this in here. I think it's just a lightning talk, so it's very short. There's actually a conference. It's called NormConf. That's going to be happening next week. Free to register if you're interested. It's kind of like basic, non-fancy data. That's kind of the pitch of the conference. That is, it's like, do you do basic non-fancy data science? Like, is your data science a little boring? This is the conference for you. So the conference itself is happening next week, but the lightning talks are up already, and Chelsea's is about the quirks of scikit-learn. And if I were to say, like, what are some great things about scikit-learn, it's that you have one unified interface to many different kinds of models. And in R, we haven't had that natively, or like a real winner, when it comes to that. Many people keep trying to make it over and over again. Like Max, who I wrote a book with and I've worked with, did Carrot. There's MLR, MLR3, and then tidy models is kind of like Max's second go at this unified interface. And I think tidy models is great and works well. And I think partly benefits from seeing what are pain points in previous iterations, like scikit-learn or Carrot. I think that some reason you might choose tidy models is that the particular kind of model that you want to try is implemented in R and not in Python. There's tons of models that are like that, right? Python has the basics. R has kind of this wild west of infinite numbers of models that exist. So so there's pros and cons to both. I think that what tidy models gets right is statistical guardrails and an interface that's going to feel ergonomic to you if you like things like using the pipe, if you like things like thinking like I do this, then I do this, then I do this, and expressing that in code. Those would be some reasons to maybe choose tidy models.
Yeah. For me personally, I think the fact that it's embedded in R is already one benefit because it's so natural to work with data in R. And,
yeah, totally.
Python's a bit more technical. Yeah. Let's see. There's one question. If you heard of Emacs peak statistics, that has nothing to do with this talk at all.
So my original computational background was C, like vanilla C, not even C++, and I wrote it all in Emacs, and this is before Git existed, and I would use rsync to make sure it was like Emacs and rsync to make sure, you know, my project was, that's how I like edited my projects and made sure the files were updated where they needed to be and all this kind of thing. So I am old enough that yes, I have experience with like Emacs. When I came to data science, like Mark said in his introduction, that was much more recent. That was 2015. And I did actually start doing some of this in Emacs. I was not aware of the ESS, like the whole, you know, like people's Emacs setups are so personal, and it's like you can spend as much time setting up your Emacs situation as you can actually writing code. It's like a whole, it's like, do you want to make your own whole developer tool chain? This is for you, you know? And I found like a little bit later in life, I just wasn't up for that, you know, like I just wasn't up for that very DIY approach to making an IDE. I wanted something that was gonna like work pretty well for most of the time, and the amount of bespoke customization I wanted to use was I like wanted to set the theme, and that's about it. So I have not specifically used the ESS toolkit, but you know, I'm very familiar with Emacs itself, and kind of I did also another thing I've been kind of interested in lately is Visual Studio Code as an editor, and I will find myself in R. I almost always continue to reach for the RStudio IDE. But if I'm writing Python, which I do now because I work on tools that are for both R and Python, I will about half the time stay in RStudio because it's actually a pretty decent IDE for Python, or about half the time I'll like end up in Visual Studio Code, which is really nice too. So that's kind of my personal editor journey.
Yes, that's recognizable. Although I did it with Vim, but you tend to make very large configuration files and then they shrink again. That's
yeah.
sort of the journey. Let's see. I think we'll do one more question and then we're going to close if you're okay with that.
Yeah.
Somebody asks, I am wondering if there is any template for data science famous visualization projects using your book, I mean.
So I think that when I hear this question, what I want to kind of reflect back on is this idea that when you're doing machine learning, you have, say, maybe roughly half the time, you need to quickly make something that has never been made before. You know, like you want to quickly do something that's very specific to your data set, and you need to customize it. Like the thing that you're trying to say requires you to build something from scratch. And then the other, really half the time, you know, in a machine learning project, you want to do something very obvious. You want to make an ROC curve. You want to make a plot after you've tuned a model to show that shows you, oh, okay, like on these different tuning parameters I tried, like how did the performance vary? Like when was it higher or lower? Like show me that. And then you're going to use like if you're using tidy models, you use something like an auto plot on the results kind of thing. And so when I think about templates, I think about trying to recognize when are the times that there is no template because I need to make something fairly custom from scratch. And when am I in a situation when I need to when I can use something that like is very basic and it's been done a zillion times, and I can just turn to one of these pre-built kind of things. So if you look, actually, if you're interested in this in R with tidy models, I'll drop a link to our book here. If you go through and you look at visualizations, it probably would be interesting to notice, when is a plot being made from scratch, like ggplot, AES, here's the X, here's the Y, blah, blah, and when is it something that's just off the shelf and we're able to use like an auto plot kind of method for some kind of object that we have. So I think that'd be an interesting thing to kind of look through the book with an eye to.
Yeah, I agree. It's difficult to make a generic trade-off that works for everybody in that sense.
Yeah, for sure, for sure.
Okay, I think we are in the end of our session. Thank you so much again, Julia, for joining us.
Thank you so much to everyone for having me. It's been a great conference so far.
So I think this concludes our session also for today. So it's well, from the Netherlands, good night to everybody. Good afternoon, I guess, on the other side of the Atlantic. And for those who are joining tomorrow, see you tomorrow.
Thank you again.
Bye-bye.
Recording stopped.
Good night.